Here onwards, we are envisioned to go to further heights from the upcoming years. I'm sure that the conference that we start from this year would be inviting many researchers from other institutions, and it would grow as a national conference in the upcoming years, or international conference. And to go to my duty of welcoming all those who have gathered here, before moving that, the only aim of this conference to set it forward is give exposure to our students, both postgraduate and undergraduate students, about various research activities that is being taken up at Christ College, and also give a flavor of multidisciplinary research that is being organized or that is being conducted at Christ College. So having a gathering like this would give other researchers from different domains an opportunity to get to know what is happening in the research areas of Christ College. That is purpose that we have restricted the research, the presentations largely to the researchers of Christ College, so that they get the opportunity to interact with each other and get to know what is happening in the research arena of Christ College. And another important aspect of having this workshop is also to get the opportunity for researchers to organize events of this magnitude. By doing that, they will be trained to do what a research meet would be and how it should be conducted in a formal manner. So these are some of the initiatives that we have planned with the leadership of our principal, who has always guided to do in this direction, so that the research at Christ College will be in a proper manner. So without taking much time, let me go to my duty of welcoming all the chief guests who have gathered here. So let me welcome our proud alumnus, Dr. Manoj P. Samuel, who was a pre-degree student here during 87-89 and later has moved into his professional career as an engineer from different institutions. He is a prompt or apt person for today's gathering because he has got very distinct ways of innovations to his credit. So in the areas of drinking water, irrigation and groundwater recharge. So Dr. Samuel has begun his career at IQAC Central Plantation Corps Research Institute, Kozhikode, in the year 1995. He has more than 150 publications to credit, with about 53 research papers in international and national peer-reviewed journals. He has published over 12 books, 33 book chapters and 69 popular articles. And he has copyright for computer software or decision support systems, and 2 design registrations and 2 patent applications being filed. So I do not need to give much introduction about a personality who is here with us today for the inauguration of a conference of this type. So he is a member of 13 international and national professional societies and a reviewer of about 19 national and international journals. And not just that, he has experience in various academic bodies as a teacher. He has worked as an adjunct professor in various colleges in Andhra Pradesh and other parts of the country. He is also member of NABL, is a certified assessor of NABL, commercial expert of Agri Innovative India Limited of ICAR, and he is a member of Transport Engineering Division Council and WRD, Hydrometry Council of BIS, and he is a member of National Institute of Hydrology, Roorkee, and so many other professional recognition that he possesses. So I do not need to further explain his background to impress upon, and it is truly a good opportunity that we have today, you with us. So I welcome you to this meeting. I also wanted to welcome now our beloved principal, Father Dr. Jolie Andrews. He is the real spirit behind the ScholarsConnect, because when we coined the idea of having a researchers forum of Christ College, he was very much enthusiastic, and he was turned on focusing a combined group of researchers at Christ College that would further instill multidisciplinary research at Christ College. So I thrust upon the vision that he has to produce multidisciplinary research at Christ College that he has always used to emphasize. So it is his guidance and support that helps the ScholarsConnect moving with a good pace. So I welcome you, Father, to this meeting. The only patent is at Christ College in the credit of Dr. V.T. Joy, who was the research nodal officer, and probably in the last years he was the face of research at Christ College, having so many innovative products that to his credit. And it was always a proud moment for us, sir, that you being among us. And unfortunately he will be retiring soon, but I'm sure that he will be continue as a research officer here, or researcher at Christ College, and your support and service will be continued here. It is a proud moment for me personally to welcome you to this meeting, sir. I welcome you to this meeting on behalf of everybody gathered here. Dr. Shinto KG, who is the IQAC coordinator of Christ College, a constant supporter of research activities at Christ College. He actually was communicating with Dr. Manoj Samuel for coming for this meeting today. So I welcome him in his absence. He is in another meeting with the ISO team at his office. He will be shortly joining with us today. So I welcome sir in his absence. It is also my privilege to welcome all the vice principals of Christ College, deans, then the bursar, Father Vincent Dennis, who will be all joining here in the morning. They are all busy with other engagements. So I welcome them for the officiality. I welcome them all to this meeting in their absence. Dear research supervisors, I welcome you all to this meeting because you are the channelizing or the catalyst for doing research at Christ College. We are very much aware that you are doing out of your passion. The research at Christ College is channelized out of the passion of the research supervisors. That is a big motivation for the students to do research in a good pace. So with all respect, I invite and I welcome all the research supervisors of Christ College who have gathered here for this meeting. Dear master students, you are here today. You were asked to sit here today because the deliberations that will be given in the inaugural session will be of your interest. We have invited students from chemistry department, students from zoology department, and students from environmental science. All these domains are related to the expertise of our chief guest today, and I am sure that you will have a very nice interactive session. Please pay attention and try to gather maximum information as possible so that you will have a good guidance in your path of forward journey. So I welcome all dear MSc students to this meeting. It is also my privilege to welcome the president, or the first president of ScholarsConnect. We have a lady president, Ms. Famy Francis, who has taken the challenge with a lot of courage in steering the wheel of ScholarsConnect for the year with the help of other office bearers. So I welcome Famy Francis to this meeting and all the office bearers of ScholarsConnect who are here. And last but not the least, let me use this opportunity to congratulate the office bearers and the members of ScholarsConnect, because they were working behind the screen all these days to make this day possible. You have seen a nice abstract volume that is being prepared by them in no time. Yesterday only we have received most of the abstract, and yesterday by midnight they have compiled it into a nice form as a abstract volume. And also all the flyers and everything has been designed meticulously by them. And every point, every progress of this meeting was very closely done by them. So I congratulate them doing everything possible to make this event possible. And I welcome them all to this meeting once again, and have a fruitful deliberation for 2 days. I wish you everything best to all the speakers, the student speakers. And we will be having 7 invited keynote speakers from various domains who will be interacting here. So I invite all the students who may be interested in various talks to attend this. There will be very provocating talks from invited speakers. One is about a meteorite crater that is newly found at Gujarat, that is initially reported by a scientist who will be giving a talk here. Another one about the Israeli-Palestinian conflict, who is a national level researcher in this aspect. So there are many things to be awaited, that is being awaited for you. So I welcome you all to this 2 days deliberation once again. Thank you. May I remain.
Thank you, sir. Next, I would like to invite Reverend Father Dr. Jolie Andrews, CMI, Principal, Christ College, Irinjalakuda, for the presidential address.
Dr. Manoj P. Samuel, the Executive Director of KSCSTE, Center for Water Resource Development and Management, Kunnamangalam, Kozhikode. Dr. V.T. Joy, Research Nodal Officer of Christ College. Dr. Linto, Alappat, the Dean of Research, Teaching Learning Center, Development College. Dr. Shinto, KG, the IQAC Coordinator. Famy Francis, the President of ScholarsConnect. Our research supervisors, research scholars, and my dear students. I am extremely happy that today our ScholarConnect is the official research forum of our Christ College is commenced and organized a 2-day Multidisciplinary National Conference and Research Expo 2024. My heartfelt appreciation to all who have toiled hard in order to make this Multidisciplinary National Conference and Research Expo a reality. My special appreciation goes to Dr. Linto Alappat, the Dean of Research, also to Famy Francis, the President ScholarsConnect, and all the office bearers of the ScholarsConnect who have made toil hard in order to make this a reality. I could see a wonderful abstract of 40 pages of the important research scenarios of our college. So why we have this multidisciplinary conference? Because we know the next age, coming age, when we do research, the industry will be asking, what is the use of it? The common man should be asking, what is it? Can you explain in our terms? So it is only if we know, interact with each other and know what is happening in the horizons of the research, especially what is happening at least in our college, we would be able to make joint research, multidisciplinary research, interdisciplinary research, and that is very vital. That is why when this year we called for the projects of PM Usha, we have specifically called for interdisciplinary projects, and when we asked for the seed money, we have specifically given priority to multidisciplinary or interdisciplinary research areas, because then only we know what is, then only it will be advantageous for us, because if we add something we get from perhaps from the other discipline, that will really make something work out. That may be something, that collaboration would be something more, in a way, intuitive in a way. That would help us to more get into some useful products, I would say, some useful concepts, more and more patents. So that is why we should always go for and strive for this multidisciplinary research conference. Here we have got Dr. V.T. Joy, one of the prime examples who has perhaps dedicated his life for research. Already has got around 5 patents and 3 more in the pipeline. A man, as I said, in the retirement function, who has already dedicated his life for the research. A man who doesn't know which is Saturday, which is Sunday, which is Monday. No difference for him. He will be coming always in that small scooter, you see it, because he doesn't know which day is which, because all days are equal for him. There is no research, there is no holiday for research. That is what he is saying. When I can always say about all the research supervisors who are sitting here, starting from Dr. Sudhi Kumar, I think last year 22, isn't it? 22 research publication, Dr. Leon in new area, I think in the ethical aspects of research area, especially the animal research scenarios he is doing. Dr. Tom Cherian, Dr. Abhilash Peter, and Dr. Bijoy C, and all doing very, very wonderful research, and myself also has joined with Dr. V.P. Joseph sir, who is also a pioneer in the metamaterial research area, and we are also doing well. Dr. Sudhir Sebastian, he is there, and he has just called me, come there, because we are physics department is today having a physics fest, They will be also having a small expo of robotics also there as a part of the physics expo, the physics research. My wholehearted appreciation to all of you, especially to the ScholarsConnects who have been here. And Dr. Manoj P. Samuel, he is our alumni, has taken all the pain to be here present for this, to deliver the inaugural address of this day. He studied a pre-degree here. Thank you so much to be present here. And he has consented that he will be present for our coming alumni meet that will be on the March 2nd Saturday. Dear researchers and students who are interested in research, get yourself involved in it, especially to all the full-time research scholar. You should be here, present for here. You should interact and know what is happening in the different scenario. So that is also mandatory for full-time research scholars of our college. Dr. Linto, you should take the attendance and everything and show to me. I will look into it. Okay. I very much appreciated the layman's talk of the ScholarsConnect. I was present for the talk of Vivek Chandran, isn't it? The research scholar of Dr. Subin. It was a wonderful talk. So some ideas you will get what we can do in that area. If I do something, some modification in my area, I can join that thing also with us. So that would be the insight that we'll have if we join together in this multidisciplinary research scenario. I'm so happy today. Let this be a wonderful beginning of the Christ College as we move forward in the realm of the research. Have a nice time. Thank you. Thank you so much.
Thank you, Father, for your kind words. Next, I warmly welcome our chief guest, Dr. Manoj P. Samuel, Executive Director, Center for Water Resources Development and Management, Kozhikode, for the inaugural address.
Good morning. President of today's function, Principal of Christ College, Irinjalakuda, Rev.Dr. Jolie Andrews, CMI, Sri Dr. B.T. Joy, Research Nodal Officer, Dr. Shinto KG, Dr. Linto Alappat, Ms. Famy Francis, other faculty members, and my dear students. I think it's a great privilege for me to come back to this institution for an official function. I passed out from this institution 36 years back. 1987 to 89, I have done pre-degree here. That time we were missing one important thing here. Can you guess that? Yeah, it was a boys only college, and our slogan was Christ College Mixed Akanam. That was one of the major slogan we used to raise. But anyway, I'm very happy to see beautiful faces over here. And I think our Reverend Father has to move to another function now. So officially I declare this function open. I will not venture into a long speech now because I have a session soon after the inaugural speech. But even though a few things, last week actually we had Kerala Science Congress at Kasaragod, and our chief guest was Professor Morten Peter Meldal. He is from Copenhagen University, Denmark. He is a chemist. He got Nobel Prize for Chemistry in 2022. And we all asked, one of the major questions he faced from the audience, which attracted you towards chemistry? His answer was simple. You can see chemistry everywhere. You can see chemistry in your life. You can see chemistry in your kitchen. You can see chemistry in your, in your vehicle. Wherever you see, you can see chemistry. Even, today is Valentine's Day. It is all about the chemistry between the people, right? So that chemistry is everywhere. Similarly, you can see physics everywhere. You can see mathematics everywhere. When you think about ISRO, because there was a PG interaction, then again to former ISRO director, Padma Shri MC Dattan, he is presently the scientific mentor to the chief minister. One of the question, why you are learning all this, calculus and, parabola and all this, people are telling nonsenses. Then he is telling, unless otherwise these things are there, you cannot make a satellite test the surface of the moon. Because all these things based on mathematical calculations, formulas, calculus and all those things, what we think nonsense is. So that you see, chemistry or whatever the sciences, it is behind everywhere. But unfortunately, our society in India or in Kerala is slowly deviating from the science. May not be deliberately, but sometimes even deliberately also. No, normally a society like India or in Kerala, we are actually stood in 4 pillars. One is our culture, our very enriched culture we have, the culture. The second is our politics. The third, politics or, government, whatever you say. And third is the religion, and fourth is science. And these 4 pillars should have equal strength. Then only the structure will be strong enough to withstand the pressures and, of course, to again grow vertically or horizontally where it is. But unfortunately, these days, the science pillar is coming thinner. Rather, the religion pillar or, the political pillar is actually getting bigger and bigger. And it is encroaching towards the science also. We are deviating from a science-driven society. What is the problem? We may not face the problem immediately, but maybe after 1 or 2 decades or 1 or 2 generations, we are going to face the problems if we are deviating from the science. You see, you look towards any developed nations, including US or European countries, all are actually, science-driven nations. There, the fundamental principles behind the development is science and technology. Unless otherwise you embrace, you accept the science as a, as a part of the life, we cannot improve upon our lifestyle or we cannot actually attain the real progress. So that is one important thing we have to think about as a science student or as a science teacher. The lost glory of science has to be regained. We have to search back again to, the importance of the science we have to bring back. The first Prime Minister, Nehru, was always looking towards the science, how the science can be actually it can be strengthened. It can be brought to, all the aspects of the national building. So we have to also think towards that particular point, which is actually a little bit deviating these days. That's why we call it research. Research. We are again searching back whether the science can be brought back. And again, these days we are speaking more about the climate change. I am actually from an institution called the Center for Water Resources Development and Management. Our institution is under Kerala State Council for Science, Technology and Environment. Basically, I am a scientist in Indian Council of Agricultural Research, and I am on deputation to CWRDM. And in CWRDM, we are working on different aspects, including all aspects of all spheres of water management, apart from that climate change as well. And these days, climate change is a big reality. The UN Secretary General recently told the days of global warming has gone, but the days of global boiling has arrived. So that is the thing. Now, last year was the hottest year on the surface of the earth. The average earth temperature has gone up to 16 degrees centigrade. 16 degrees centigrade. You may think 16 degrees a very low temperature, but it's an average temperature. The temperature including Arctic and Antarctic altogether, I'm telling the average is 16 degrees centigrade. It is a too high temperature. The average global temperature rise from the 1890s. What is the peculiarity of 1890s? When the industrial era started. From that decade only we start counting for global warming. Now the average global temperature in this year has gone up to 1.5 degrees centigrade. That is considered to be the threshold temperature. And by the end of this century, the global temperature may reach up to 2 degrees centigrade plus from the industrial revolution era. So that you see, if the global temperature goes up to 2 degrees centigrade or 1.5 degrees centigrade, it is already reached. It is actually going to affect us in different ways. The climate related disasters are going to increase. All over the world now almost 1,000 plus disasters are happening, whether it is a heat wave, whether it is a flood, whether it is a landslide or whatever it is, different types of disasters. The events are increasing across the globe. Even a few days back, there was a heat wave, some part of, I think it is in South America, and many people have actually, they have been killed. Even in America, a developed country, last year, in Miami, there was a wildfire and more than 100 people died. In America, we cannot expect this in such an advanced country like America. So that, climate change is a reality. It has reached up to our doorstep. Some of you, it might have even entered your house in last floods. So that, we have to be prepared. And especially for the younger generation, you have to be more prepared, because when you reach our age, the disasters will be in many folds. So how we can tackle it? So that there are two approaches, as all of you know. We can try to mitigate the climate change. That's why we are actually looking towards reducing the global warming by means of reduction in emission and increasing the sequestration potential. So that net zero, our Prime Minister told by 2070 India will be a net zero country. Our Chief Minister told Kerala, carbon neutral Kerala will be a reality by 2050. So these all are the things for mitigation. But on the other side, we have to also think about the adaptation. Climate change is a reality, and at the same time we have to live along with that, right? So how we can change our lifestyle, how we can change our cropping pattern, how you can change our way of using our resources, including water. So that is climate adaptation. So that legugarnu porithappadalum, these two are very important. So we will be discussing much about these things when I actually speak to you with my slides. And once again, I thank all of you for inviting me for this function. I'm very happy to come here because it's a very beautiful campus. I started my academic after the schooling from this beautiful green campus. And after that, wherever I go, it was green because I started from here. Actually, after that, I went to Kerala Agriculture University. It was also a green campus. Then IIT Kharagpur, that was also much greener. Then again, Tamil Nadu Agriculture University. That is also a beautiful campus. So everything started from this Christ College, and we have a very, a lot of love to this college because we have a lot of good friends, networks. Even now we have a very active WhatsApp group. Our pre-degree friends, all are actually spread across the globe. So that all the friendships started from here. So that I am thankful to this campus also. So that once again I thank the organizers, respected father, and all the dignitaries on and off the dais for inviting me and giving me this opportunity. Thank you very much.
Thank you, sir. Now, I invite Dr. V.T. Joy, Research Nodal Officer and Head of the Department of Chemistry, for felicitation.
ഇന്നത്തെ ഈ 2-day Multidisciplinary National Conference and Research Expo 2024 CWRDM Kozhikode പ്രസിഡന്റ് അഡ്രസ് നൽകിയ Rev.Dr. ജോളി ആൻഡ്രൂ CMI, നമ്മുടെ ക്രൈസ്റ്റ് ഡീൻ ഓഫ് റിസർച്ച് ഡോക്ടർ ലിൻറ്റോ ആലപ്പാട്ട്, ഇന്നത്തെ IQAC കോർഡിനേറ്റർ, ഇന്ന് ഫെലിസിറ്റേഷൻ നൽകുന്ന IQAC കോർഡിനേറ്റർ ഷിൻറ്റോ KG, പിന്നെ ഇതിൻ്റെ പ്രസിഡൻറ്റ്, ഈ ScholarsConnectൻ്റെ പ്രസിഡൻറ്റ് മിസ് ഫെമി ഫ്രാൻസിസ്, ഇത് റിസർച്ച് സൂപ്പർവൈസേഴ്സ്, റിസർച്ച് സ്റ്റുഡൻസ് ആൻഡ് മൈ ഡിയർ PG സ്റ്റുഡൻസ്. അപ്പോൾ ഞാൻ ഈ വർഷം മെയ് 31 റിട്ടയർ ചെയ്യാണ്. എൻ്റെ ഫെയർവെൽ മീറ്റിംഗൊക്കെ കോളേജിൽ നിന്ന് തന്നു കഴിഞ്ഞു. അപ്പോൾ സാധാരണ ഇതിൽ റിട്ടയർ മോഡിങ്ങിലാവേണ്ടതാണ്, പക്ഷേ എൻ്റെ കേസിൽ നേരെ തിരിച്ചാണ്. കാരണം കുറേ റിസർച്ച് പ്രോജക്ട്സൊക്കെ തുടങ്ങിയിട്ടുണ്ടായിരുന്നു, അതൊക്കെ അവസാനിപ്പിക്കണം. അപ്പോൾ സത്യം പറഞ്ഞാൽ ഞാൻ ലീവിലാണ്, ലീവ് എടുത്തിട്ടാണ് ആ വർക്കൊക്കെ ചെയ്യുന്നത്. കമ്മ്യൂട്ടർ ലീവ് എടുത്തിരിക്കുകയാണ്. അപ്പോൾ എൻ്റെ ജേണിയെ കുറിച്ച് പറയുകയാണെങ്കിൽ ഞാനിവിടെ 83 to 90 ഇവിടെ പഠിച്ചതാണ്. പ്രീ ഡിഗ്രി തൊട്ട് PG വരെ ഇവിടെ പഠിച്ചതാണ്. അപ്പോൾ സാറ് സൂചിപ്പിച്ച പോലെ പഠിക്കുന്ന കാലത്ത് ഇവിടെ ബോയ്സ് മാത്രമേ ഉണ്ടായിരുന്നുള്ളൂ, പിന്നെ പഠിപ്പിക്കാൻ വന്നപ്പോൾ മുഴുവൻ ഗേൾസായി. അങ്ങനെയാണ്. പിന്നെ വർക്കിനെ കുറിച്ചൊക്കെ പറയുകയാണെങ്കിൽ കുറേ പ്രോജക്ട്സൊക്കെ എനിക്ക് സ്റ്റാർട്ട് ചെയ്യാൻ പറ്റി, അതൊക്കെ നല്ലൊരു രീതിയിൽ പോയിക്കൊണ്ടിരിക്കുന്നു. കേട്ട് ഇപ്പോൾ കുറച്ചൊക്കെ നിങ്ങൾക്കൊരു ഇൻസ്പിറേഷൻ കിട്ടാനായിട്ട് ഞാൻ പറയണു. ഇപ്പോൾ ഈ മൾട്ടിപ്പിൾ ഡിസിപ്ലിനറി റിസർച്ചൊക്കെയാണ് ഇവിടെ പറയുന്നത്. അപ്പോൾ ഞാൻ ആദ്യമായിട്ടൊരു എൻ്റെ മുടി നരച്ചു തുടങ്ങിയപ്പോൾ ഞാൻ ഒരു ഹെയർ ഡേയെ കുറിച്ച് ആലോചിച്ചു. അങ്ങനെ ഒരു ഹെയർ ഡേ, അത് ഇപ്പോൾ സാധാരണ കിട്ടുന്ന ഡൈസൊക്കെ നിങ്ങൾക്കറിയാം, PPD എന്ന് പറഞ്ഞ കെമിക്കലുള്ളതാണ്. PPD എന്ന് പറയുന്നത് എന്താണ്? പാരഫെനിൽ ഡയമീൻ. അത് കാർസിനോജനിക്കാണ്. നമുക്ക് അത് ശരിക്കും കാർസിനോജനിക്കാണ്. കാരണം അത് ഇത് നമ്മൾ തലയിലേക്ക് പുരട്ടി കഴിഞ്ഞാൽ നമുക്ക് ലിവർ ക്യാൻസർ അങ്ങനെയൊക്കെ സാധ്യതയുണ്ട്. അപ്പോൾ ഞാനത് എന്തായാലും അത് ഉപയോഗിക്കില്ല എന്ന് വിചാരിച്ചു. അങ്ങനെ കുറച്ച് വർക്കൊക്കെ ചെയ്തു, കുറേ റിസർച്ച് ചെയ്തു, ഒരു 10 കൊല്ലമൊക്കെ ചെയ്തു. അവസാനം ഒരു ഹെയർ ഡേ, നാച്ചുറൽ ഹെയർ ഡേ ഡെവലപ്പ് ചെയ്യാനായിട്ട് പറ്റി. അപ്പോൾ ഇവിടെ അപ്പോൾ അത് കണ്ടുപിടിക്കാനുള്ള ബുദ്ധിമുട്ട് എന്നെ സംബന്ധിച്ച് ഏറ്റവും സംബന്ധിച്ച് മാർക്കറ്റിംഗ് ആണ്. നമുക്ക് മാർക്കറ്റിങ്ങിലൊന്നും വലിയ എക്സ്പീരിയൻസ് ഇല്ലല്ലോ, നമ്മളിവിടെ ടീച്ചേഴ്സാണ് ബേസിക്കലി. അപ്പോൾ അത് മാർക്കറ്റ് ചെയ്യണം. ഇപ്പോൾ ഞങ്ങൾ ഈ മണപ്പുറം ഫൈനാൻസ് അവരൊരു കോസ്മെറ്റിക് ഡിവിഷൻ തുടങ്ങിയിട്ടുണ്ട്. അവരായിട്ട് ഇങ്ങനെ കൺസൾട്ട് ചെയ്തുകൊണ്ടിരുന്നത്, അവർ താല്പര്യം കാണിച്ചിട്ടുണ്ട്. ഒരു പക്ഷേ അവരത് ഏറ്റെടുത്ത് മാർക്കറ്റിലെത്തിയേക്കാം. അങ്ങനെയാണ്. പിന്നെ നമ്മൊരു സോളാർ ഡ്രയർ ഡെവലപ്പ് ചെയ്തിട്ടുണ്ടായിരുന്നു. ആ സോളാർ ഡ്രയർ ഈ ഡൽഹിയിൽ ഉന്നത് ഭാരത് അഭിയാൻ പ്രോഗ്രാമിൽ അത് സെലക്ട് ചെയ്യപ്പെട്ട് നമ്മൾ അവിടെ പോയിട്ടുണ്ടായിരുന്നു. കേരളത്തിൽ ഫസ്റ്റായിട്ട് നമ്മൾ പോയി. അവിടെ വെച്ചിട്ട് നമുക്ക് അത് 15 ബെസ്റ്റ് റൂറൽ ടെക്നോളജിയിൽ സെലക്ഷൻ കിട്ടി. അങ്ങനെ കേട്ട്. പിന്നെ മൂന്നാമതായിട്ട്, അപ്പോൾ ഈ മൾട്ടി ഡിസിപ്ലിനറി റിസർച്ചായിട്ട് പറയാം, മൂന്നാമതായിട്ട് നമ്മൊരു ഹെർബൽ മെഡിസിൻ ഡെവലപ്പ് ചെയ്ത്, അതായത് എക്സിമ എന്ന് പറഞ്ഞ അസുഖത്തിനോടാണ്. എക്സിമ നിങ്ങൾക്കറിയാം, എക്സിമയ്ക്ക് ഇപ്പോൾ ക്യൂറില്ല. നിങ്ങൾ ഡോക്ടർമാരുടെ അടുത്ത് വെച്ചാൽ പറയും ദർ ഇസ് നോ ക്യൂർ ഫോർ എക്സിമ എന്നാണ് പറയുന്നത്. പക്ഷേ നമ്മുടെ മെഡിസിൻ പല ആളുകളിലും അത് വർക്ക് ചെയ്തിട്ടുണ്ട്, അത് നല്ല ക്യൂർ കിട്ടിയിട്ടുണ്ട്. മാത്രമല്ല ഈ ഫുഡ് ക്രാക്കിംഗ് എന്ന് പറഞ്ഞ അസുഖം, ഫുഡ് ക്രാക്കിംഗ് എന്ന് പറഞ്ഞാൽ വളരെ സിവിയർ കേസസ് ഫുഡ് ക്രാക്കിംഗ്, ഈ ബ്ലീഡിംഗ് ഉള്ള ഫുഡ് ക്രാക്കിംഗ് പോലും ആ മരുന്നുകൊണ്ട് മാറുന്നതായിട്ടാണ് ഞങ്ങൾ കണ്ടത്. ഞങ്ങളുടെ ക്ലിനിക്കൽ ട്രയൽസൊക്കെ നടന്നുകൊണ്ടിരിക്കുന്നു. അപ്പോൾ 2 സ്റ്റുഡൻസ്, മിസ് ഡെയ്ഫി ഡേവിസ് ആൻഡ് മിസ് അമൃത സുരേഷ് ഇവിടെയുണ്ട്. ഡെയ്ഫി ഡേവിസ് റിസർച്ച് സ്കോളറാണ്. അവർ YIP പ്രോഗ്രാമിൽ പങ്കെടുത്തവർക്ക് സ്റ്റേറ്റ് ലെവലിൽ കിട്ടിയിട്ടുണ്ടായിരുന്നു. അവർ വിൻ ചെയ്തിട്ടുണ്ടായിരുന്നു, അവർക്ക് ഫണ്ടിങ് കിട്ടിയിട്ടുണ്ടായിരുന്നു. പിന്നെ നമ്മൊരു ബയോഗ്യാസ് പ്ലാന്റ്, അത് അധികം യൂണിറ്റ് ഇൻസ്റ്റാൾ ചെയ്യാൻ പറ്റിയിട്ടില്ല. ആ ബയോഗ്യാസ് പ്ലാന്റ് പ്രത്യേകത, സാധാരണ ബയോഗ്യാസ് പ്ലാന്റ് കത്താനൊക്കെ ബുദ്ധിമുട്ടാണ്. അപ്പോൾ നമ്മൾ ഈ മുനിസിപ്പാലിറ്റിയിൽ നിന്ന് കിട്ടുന്ന ബയോഗ്യാസ് പ്ലാന്റൊക്കെ വീട്ടിൽ ഇൻസ്റ്റാൾ ചെയ്ത് കഴിഞ്ഞാൽ പലരും അത് സ്റ്റോപ്പ് ചെയ്തു, കാരണം അത് ശരിക്കും വർക്ക് ചെയ്യണില്ല. അപ്പോൾ ഞാൻ ഡിസൈൻ ചെയ്ത ബയോഗ്യാസ് പ്ലാന്റ് നന്നായി കത്തുന്നുണ്ട്. സാധാരണ ലൈറ്റർ ഉപയോഗിച്ച് ബയോഗ്യാസ് ഇത് കത്തില്ല, ബയോഗ്യാസ് കത്താൻ ബുദ്ധിമുട്ടാണ്. പക്ഷേ എൻ്റെ ബയോഗ്യാസ് അതിൽ കത്തുന്നുണ്ട്. അപ്പോൾ അതിൻ്റെ CO2 എമൗണ്ട് കുറവായിരിക്കണം. അപ്പോൾ അതിൽ കുറച്ചും കൂടിയും ഇന്നോവേഷൻ നടത്തി അത് മാർക്കറ്റിലെത്തിക്കണം വിചാരിക്കണം. അതിന് ഞാൻ ഈ കുറച്ച് കൊളാബറേഷനൊക്കെ നോക്കിക്കൊണ്ടിരിക്കുകയാണ്. പിന്നെ എൻ്റെ ബേസിക് വർക്ക് എന്ന് പറഞ്ഞാൽ ഞാൻ ഫ്യൂവൽ സെൽ ബാറ്ററീസിലേക്കാണ് വർക്ക് ചെയ്യുന്നത്. അപ്പോൾ എൻ്റെ ഇപ്പോൾ ഒരു പേറ്റൻറ്റ്, US പേറ്റൻറ്റ് കിട്ടിയത് ഒരു സിങ്ക് ബാറ്ററിയുടെ ആനോട്ടിൻ്റെ പ്രോബ്ലം ഡെൻഡ്രൈറ്റ് ഇഷ്യൂ എന്ന് പറഞ്ഞത്. ഡെൻഡ്രൈറ്റ് എന്ന് പറഞ്ഞാൽ സാധാരണ സിങ്ക് ഡെപ്പോസിറ്റ് ചെയ്യുമ്പോൾ യൂണിഫോമായിട്ട് ഡെപ്പോസിറ്റ് ചെയ്യില്ല. ഈ ഒരു ബാറ്ററിയിൽ നടക്കുന്നത് ചാർജിങ് ഡിസ്ചാർജിങ് ആണ്. ആ ചാർജ് ചെയ്യുന്ന സമയത്ത് സിങ്ക് ഡെപ്പോസിറ്റ് ആണ് ചെയ്യുന്നത്, പക്ഷേ അത് യൂണിഫോമായിട്ട് ഡെപ്പോസിറ്റ് ചെയ്യില്ല. അപ്പോൾ അത് സോൾവ് ചെയ്യാനായിട്ട് ഒരു ടെക്നോളജി നമ്മൾ ഡെവലപ്പ് ചെയ്തു. ഒരു US കമ്പനി ആ ടെക്നോളജി താല്പര്യമുണ്ടെന്ന് പറഞ്ഞു. അങ്ങനെ ഞങ്ങൾ അവിടെ ഒരു ഫാസ്റ്റ് ട്രാക്കിൽ അപ്ലൈ ചെയ്തു. അങ്ങനെ 6 മാസം കൊണ്ട് ഞങ്ങൾക്ക് ആ US പേറ്റൻറ്റ് ഗ്രാൻഡ് ചെയ്തു. പിന്നെ ഞാനിപ്പോൾ ആ വർക്ക് കണ്ടിന്യൂ ചെയ്തുകൊണ്ടിരിക്കുകയാണ്. അപ്പോൾ ഇപ്പോൾ അച്ഛൻ സൂചിപ്പിച്ച പോലെ ഞാൻ ശനി ഞായർ കൂടി ഉണ്ട്. ഒരു പക്ഷേ റിട്ടയർ ചെയ്യുന്ന കൊല്ലത്തിലാണ് ഏറ്റവും അധികം വർക്ക് ചെയ്തിരിക്കുന്നത്. സാധാരണ 7 മണിക്കൊക്കെ വന്ന് ഇവിടെ വർക്ക് ചെയ്യുന്നുണ്ട്. അതിന് മെയിൻ കാരണം ഈ വർക്ക് കംപ്ലീറ്റ് ചെയ്ത് പോകണമെന്നുണ്ട്. അപ്പോൾ ഈ മെയ് 31 എൻ്റെ സൂപ്പർ ആനിവേഴ്സൺ ഡേ. അതിന് മുമ്പ് ഈ വർക്ക് കംപ്ലീറ്റ് ചെയ്യണമെന്ന് വിചാരിച്ചുകൊണ്ട് വർക്ക് ചെയ്തുകൊണ്ടിരിക്കുന്നു. അങ്ങനെ ഞങ്ങൾ പല വർക്കുകൾ ഇപ്പോൾ പെൻഡിങ്ങിലാണ്. ഇപ്പോൾ എൻ്റെ സ്റ്റുഡൻസ് ഉണ്ട്. ഇപ്പോൾ ഫെമി ഫ്രാൻസിസ് ആൾ ചെയ്യുന്ന ഒരു മെംബ്രെയിനാണ്. ആ മെംബ്രെയിൻ തന്നെ ഈ ബാറ്ററീസിൽ കണ്ടമാനം ആപ്ലിക്കേഷൻ ഉള്ളതാണ്. ബാറ്ററിയുടെ സെപ്പറേറ്ററായിട്ട് യൂസ് ചെയ്യുന്ന ഒരു ഇതാണ് മെംബ്രെയിൻ. ഇപ്പോൾ ഫെമി ചെയ്യുന്നത് ഒരു ആനിയോൺ എക്സ്ചേഞ്ച് മെംബ്രെയിൻ ഡെവലപ്പ് ചെയ്തുകൊണ്ടിരിക്കുകയാണ്. പിന്നെ ഞങ്ങൾക്കിപ്പോൾ ഏറ്റവും വലിയൊരു അച്ചീവ്മെൻ്റ് ആയിട്ട് ഞങ്ങൾക്ക് പറയാവുന്നത് ഗ്രാഫീൻ. നിങ്ങൾക്ക് കേട്ടിട്ടുണ്ടാവും. ഗ്രാഫീൻ എന്ന് പറഞ്ഞാൽ എന്താണ്? ഗ്രാഫൈൻ്റെ ഒരു 2D ലെയറാണ്. ഇത് കണ്ടുപോകാൻ ആപ്ലിക്കേഷൻസ് ഉണ്ട്. നമ്മൾ ആലിസ് ഇൻ വണ്ടർലാൻഡ് എന്ന് കേട്ടില്ല, അതേപോലെ ഞങ്ങൾ ഈ ഇതിൻ്റെ ഗ്രാഫിൻ്റെ വണ്ടർലാൻഡിലാണ് ഞങ്ങൾ നേട്ടങ്ങൾ കൊയ്തുകൊണ്ടിരിക്കുകയാണ് ഇവിടെ. കാരണം ഇപ്പോൾ നിങ്ങൾക്ക് ഇൻ്റർ ഡിസിപ്ലിനറി റിസർച്ച് ചെയ്യുന്നവർക്ക് ഗ്രാഫിൻ ഞങ്ങൾക്ക് വേണമെങ്കിൽ സപ്ലൈ ചെയ്യാൻ പറ്റും. 1 ഗ്രാമിന് നിങ്ങൾ മാർക്കറ്റിൽ നിന്ന് വാങ്ങണേ എൻ്റെ വില 10,000 റുപ്പീസാണ്. ഞങ്ങൾ നിങ്ങൾക്ക് ഫ്രീ ആയിട്ട് തരാം ഗ്രാഫിൻ, കാരണം നമ്മൾ ഉണ്ടാക്കുന്നുണ്ട്. അപ്പോൾ നിങ്ങളുടെ ഫീൽഡിലൊക്കെ സെർച്ച് ചെയ്താൽ നിങ്ങൾക്ക് എന്തായാലും ഗ്രാഫിൻ്റെ ആപ്ലിക്കേഷൻ കണ്ടെത്താൻ പറ്റും. ഏതിലായാലും, സുവോളജി ആയാലും ഫിസിക്സിലായാലും. അപ്പോൾ ഏറ്റവും നല്ലൊരു കോമ്പൗണ്ടാണ് ഗ്രാഫിൻ. ഞങ്ങളതിൽ മാക്സിമം നേട്ടങ്ങൾ കൊയ്തുകൊണ്ടിരിക്കുകയാണ്. ഇപ്പോൾ ഈ പലരും വർക്ക്, ഇപ്പോൾ ഈ വാട്ടർ സ്പ്ലിറ്റിങ്ങിൽ ഹൈഡ്രജൻ എവല്യൂഷൻ റിയാക്ഷൻ, അതുപോലെ ഓക്സിജൻ എവല്യൂഷൻ റിയാക്ഷൻ, അതാണ് കീ റിയാക്ഷൻസ്. അപ്പോൾ അതിനൊക്കെ ഞങ്ങൾ ഉണ്ടാക്കുന്ന കാറ്റലിസ്റ്റ് ഗ്രാഫിൻ ഉപയോഗിച്ചിട്ടാണ്. അതുപോലെ ഞങ്ങളുടെ സിങ്ക് ബാറ്ററീസിൽ ഞങ്ങൾ അതാണ് ഉപയോഗിക്കുന്നത്. മെംബ്രെയിനിൽ ഇപ്പോൾ ഉപയോഗിക്കുന്നത് ഗ്രാഫിനാണ്. അപ്പോൾ ഗ്രാഫിൻ ഉപയോഗിച്ചിട്ട് കുറേ കാര്യങ്ങൾ ഞങ്ങൾക്ക് ചെയ്യാൻ പറ്റുന്നുണ്ട്. ഇനി ഇപ്പോൾ ഏറ്റവും അവസാനമായിട്ട് ഞങ്ങൾക്കിപ്പോൾ ഒരു പുതിയ ബാറ്ററി ഡെവലപ്പ് ചെയ്തുകൊണ്ടിരിക്കുകയാണ്. അത് സിങ്ക് അയഡിൻ ബാറ്ററിയാണ്. ഈ ബാറ്ററിയുടെ പ്രത്യേകത, ഇപ്പോൾ നമ്മൾ ഗ്രീൻ ടെക്നോളജി എന്ന് പറഞ്ഞത് നമ്മളെല്ലാവരും വാങ്ങുന്നത് ലെഡ് ആസിഡ് ബാറ്ററിയാണ്. ഈ ലെഡ് ആസിഡ് ബാറ്ററി ഒരിക്കലും ഗ്രീൻ ടെക്നോളജി ആയിട്ട് കൺസിഡർ ചെയ്തതാണ് എൻ്റെ അഭിപ്രായം. കാരണം ലെഡ് ഹൈലി പോയ്സണസ് ആയിട്ടുള്ള മെറ്റീരിയലാണ്. അത് ന്യൂറോടോക്സിക് ആയിട്ടുള്ള മെറ്റീരിയലാണ്. നമ്മൾ യൂസ് ചെയ്ത് എന്തായാലും ഇത് ഡിസ്പോസ് ചെയ്ത് നമ്മുടെ വാട്ടർ ബോഡീസിലേക്ക് എത്തിച്ചേരുമ്പോൾ അത് നമ്മുടെ ശരീരത്തിൽ ചേർന്ന് കഴിഞ്ഞാൽ അത് ഹൈലി ടോക്സിക് ആയിട്ടുള്ള മെറ്റലാണ്. അപ്പോൾ ഇപ്പോൾ ഈവൻ ലെഡ്, ഇപ്പോൾ ഈ ആംറോൺ എന്ന് പറഞ്ഞ കമ്പനി, എൻ്റെ ഒരു ഫ്രണ്ട് ഇവിടെ വർക്ക് ചെയ്യുന്നുണ്ട്, സീമെറ്റിൻ്റെ ഡയറക്ടറാണ്. അപ്പോൾ അവിടുത്തെ ഈ വാട്ടർക്ക് ടെസ്റ്റ് ചെയ്യാനായിട്ട് ആളെ ലാബിലേക്കാണ് വന്നത്. അപ്പോൾ ടെസ്റ്റ് ചെയ്തപ്പോൾ കണ്ടമാനം ലെഡ് കലർന്നുണ്ടെന്ന് പറഞ്ഞു. അപ്പോൾ ആ കമ്പനി പൂട്ടാൻ ഗവൺമെൻറ് ഓർഡർ കൊടുത്തു. ഈ ആംറോൺ എന്ന് പറഞ്ഞ കമ്പനി ഇപ്പോൾ ഹൈദരാബാദിലെ കമ്പനി പൂട്ടിയതായിട്ടാണ് ഞാൻ അറിഞ്ഞത്. കാരണം ലെഡ് ഇതാണ് പോയ്സണസ് കാരണം. അപ്പോൾ അങ്ങനെ ലെഡിൻ്റെ കാലം കഴിഞ്ഞു. അപ്പോൾ ഇനി അടുത്തത് ഇപ്പോൾ ലിഥിയൻ ബാറ്ററീസ് ഉണ്ട്, പക്ഷേ അത് ഭയങ്കര എക്സ്പെൻസീവ് ആണെന്ന് നമുക്കറിയാം. അപ്പോൾ ഇപ്പോൾ ഇതിന് ഞങ്ങൾ ചെയ്യുന്നത് സിങ്ക് ബേസ്ഡ് ബാറ്ററീസാണ്. സിങ്ക് അതിന് കുറേ അഡ്വാൻറ്റേജസ് ഉണ്ട്. അത് ചീപ്പാണ്, മാത്രമല്ല അത് ഫ്ലെയിമബിൾ അല്ല, തീ പിടിക്കില്ല, കാരണം അതിൽ വാട്ടറാണ് സോൾവൻ്റായിട്ട് ഉപയോഗിക്കുന്നത്. അപ്പോൾ ഞങ്ങൾ അതിൽ ഈ സിങ്ക് ആയഡൻ ബാറ്ററിയിൽ ഞങ്ങൾക്ക് നല്ലൊരു റിസൾട്ട് കിട്ടി. ഇപ്പോൾ അതിൻ്റെ എനർജി ഡെൻസിറ്റി നോക്കുകയാണെങ്കിൽ ഈ ലെഡ് ആസിഡ് ബാറ്ററിയേക്കാളും 3 times ഹയർ ആണ്, 3 ഇരട്ടി. ലെഡ് ആസിഡ് ബാറ്ററിയുടെ 35 Wh/kg ആണെങ്കിൽ സിങ്ക് ആയഡൻ ബാറ്ററിയുടെ കിട്ടുന്നത് 100 ആണ്. അങ്ങനെ ഞങ്ങൾ വലിയ കമ്പനികളൊക്കെ ആയിട്ട് കോൺടാക്ട് ചെയ്തിട്ടുണ്ട്. ഏതെങ്കിലും കമ്പനി ഞങ്ങളുടെ ടെക്നോളജി ഏറ്റെടുക്കുമെന്ന് വിചാരിക്കുന്നു. അപ്പോൾ എനിക്ക് നിങ്ങളോട് പറയാനുള്ളത്, ഈ ക്രൈസ്റ്റ് ഓയിൽ വന്നിട്ട് ഒരു പക്ഷേ എൻ്റെ ഒരു മിഷൻ പോലെയാണ് ഞാൻ അത് കാണുന്നത്. ഞാനിപ്പോൾ ഈ എൻ്റെ PhD 99 IIT കഴിഞ്ഞു. അത് കഴിഞ്ഞ് എനിക്ക് ഒരു 5 വർഷത്തോളം പോസ്റ്റ് ഡോക്ടറൽ വർക്കായിട്ട് ഫോറിൻ യൂണിവേഴ്സിറ്റിക്ക് വർക്ക് ചെയ്യാൻ അവസരം കിട്ടി. പക്ഷേ എന്നാലും എനിക്ക് നാട്ടിൽ വന്ന് എന്തെങ്കിലും ചെയ്യണമെന്നാണ്, നമ്മുടെ നാട്ടുകാർക്ക് ഉപകാരപ്രദമായ എന്തെങ്കിലും ചെയ്യണം എന്നുള്ള ആഗ്രഹത്തോടു കൂടി ഞാൻ ഇങ്ങോട്ട് വന്നത്, തിരിച്ച് വന്ന് അങ്ങനെ 2004 തുടങ്ങി ഇപ്പോൾ 20 വർഷം ആവുന്നു. അപ്പോൾ കുറേ കാര്യങ്ങളൊക്കെ എനിക്ക് നല്ലതായിട്ട് ചെയ്യാൻ പറ്റുമെന്ന് ഞാൻ വിശ്വസിക്കുന്നു. അതിൽ ഏറ്റവും അവസാനത്തെയാണ് ഈ ബാറ്ററി. ഈ ബാറ്ററി ഒരു ഗെയിം ചേഞ്ചർ ആയിരിക്കും ഞാൻ വിചാരിക്കുന്നു. കാരണം ഈ ലെഡ് ആസിഡ് ബാറ്ററി റീപ്ലേസ് ചെയ്യാം. നമ്മുടെ ഇപ്പോൾ ഒരു പക്ഷേ 95% ബാറ്ററി മാർക്കറ്റും ലെഡ് ആസിഡ് ബാറ്ററി ആയിട്ട് കണക്ട് ചെയ്തിരിക്കുകയാണ്. എല്ലാ സോളാർ പാനൽസിലും ഉപയോഗിക്കുന്ന ലെഡ് ആസിഡ് ബാറ്ററിയാണ്. അപ്പോൾ അത് റീപ്ലേസ് ചെയ്യാൻ പറ്റുകയാണെങ്കിൽ തന്നെ അത് വലിയൊരു നേട്ടമായി കരുതുന്നു. അപ്പോൾ ഇതൊക്കെ ചെയ്യാൻ സാധിച്ചത് ഇവിടുത്തെ സൗകര്യങ്ങൾ, ഈ ക്രൈസ്റ്റ് കോളേജ് നമുക്ക് എപ്പോഴും ലാബൊക്കെ ഓപ്പൺ ചെയ്ത് തന്നുകൊണ്ടാണ്. അപ്പോൾ അതിനൊക്കെ മാനേജ്മെൻറ്റിനോട് പ്രിൻസിപ്പലിനോടൊക്കെ പ്രത്യേകം നന്ദി പറയുകയാണ്. അപ്പോൾ ഈ പ്രോഗ്രാം ഇത് ഓർഗനൈസ് ചെയ്ത ലിൻഡോ സാറിനൊക്കെ കൺഗ്രാജുലേഷൻസ്. പിന്നെ ബാക്കി ഓഫീസ് ബെയറേഴ്സിനും എല്ലാം എല്ലാവിധ ആശംസകളും നേരുന്നു. ക്രൈസ്റ്റ് കോളേജ് ഇനി വലിയ ഉന്നതിയിലേക്ക് എത്തട്ടെ എന്ന എല്ലാ ആശംസകളോടുകൂടി സ്റ്റുഡൻസിനോട് എനിക്ക് ഒറ്റൊരു മെസ്സേജ് ഉള്ളത്, പെർസീവറൻസ് എന്നൊരു വേർഡ് കേട്ടിട്ടുണ്ട്, അബ്ദുൽ കലാമൊക്കെ യൂസ് ചെയ്യുന്ന വേർഡാണ്. അതായത് നിങ്ങൾക്ക് ഒരു പ്രോബ്ലം കിട്ടുകയാണെങ്കിൽ നിങ്ങൾ അതിനെ കണ്ടിന്യൂ ചെയ്യുക. അതായത് പ്രോബ്ലംസൊക്കെ വരും, അതൊക്കെ സോൾവ് ചെയ്യാൻ പറ്റും. അപ്പോൾ അത് എന്താ പറയുക, വിടാതെ പിടിക്കുക, അതിന് പിന്നാലെ തന്നെ പോവുക. ആ പ്രോബ്ലം നിങ്ങൾക്ക് സോൾവ് ചെയ്യാൻ പറ്റും. അപ്പോൾ നിങ്ങൾക്ക് എല്ലാവർക്കും എല്ലാവിധ ആശംസകളും നേർന്നുകൊണ്ട് നിർത്തട്ടെ.
Thank you, sir, for your enlightening words. Next, I invite Dr. Shinto KG, IQAC Coordinator, Christ College, Irinjalakuda, for the felicitations.
Dear respected Principal, Father Dr. Joel Andrew CMI, today's Chief Guest, Resource Person, Dr. Manoj P. Samuel, dear respected Joy Sir, Linto Sir, dear research supervisors, research scholars, and my dear students. First of all, I express my sincere gratitude for inviting me to be a part of this research scholar program. On behalf of IQAC, I congratulate the research family of Christ College, especially Dr. Linto Alappat, Dr. B.T. Joy, and all other research supervisors, research scholars, for promoting the research culture or research activities in this campus. I am just thinking about my research days in NIT Calicut, and I am thinking about or enjoying that days or in organizing such programs, especially interacting with the experts of industry and academicians. That things I was just remembering that things here. Anyway, I am sure I can agree all of you that this kind of programs will give you more and more pathways for multidisciplinary and interdisciplinary research options. There is no doubt. Today's resource person, chief guest, Dr. Manoj P. Samuel, actually he is a member of our academic council, expert from alumni science stream, and because of his busy schedules, he cannot even attend a single offline academic council meeting in our campus. Last time when I invited him to attend our academic council meeting, he assure that he will definitely attend. If you arrange any research based program in this campus, he will definitely attend the program. So today he's with us. Actually, I'm his fan. I can say that because every day I just want to check his WhatsApp status. If you consider a particular week of his life, if it is a Sunday, he may be in Calicut, Kunnamangalam. The very next day we can see that he's saying his status, saying that he's in Rajasthan or Delhi or Mumbai, like that. The very next day he is attending some program in Kasaragod or Trivandrum in this state. Okay, so I don't know how he is managing all these things. Every day I think he's traveling that much. And I think he's a frequent visitor of the foreign countries also. So we are so lucky that we have such a eminent resource person. I think we can all utilize his expertise, and I wish all of you a good 2 days, fruitful 2 days here. Thank you. Thank you.
Thank you, sir. As our token of respect and gratitude, we would like to present a gift on the behalf of Christ College and Research Forum to our chief guest. For this, I welcome our chief guest receive, and I also welcome Reverend Father Jolly Andrews to honor him with our gift, and I also welcome every other dignitaries to join. Last but not least, I invite Ms. Famy Francis, President, ScholarsConnect, for the vote of thanks.
Good morning to most venerated Chief Guest, Dr. Manoj P. Samuel, Executive Director, KSCSTE Center for Water Resource Development and Management, present dignitaries, worthy delegates, worthy research supervisors, dear researchers and students. I take it as the most opportune moment to express profound gratitude to the august assemblage of the all dignitaries who partook the glory of this national conference. I, on behalf of the organizing committee, deep regards and hearty thanks to our honorable chief guest, Dr. Manoj P. Samuel. Thank you. Thank you very much, sir. I am also thankful to the principal, Rev.Dr. Jolie Andrew CMI, for his constant guidance and support. Thank you. Thank you very much, Father. My special thanks to Dr. Linto Alappat, Dean of Research, for his great support and guidance for this national conference. Thank you, sir. I would also extend my thanks to Dr. B.T. Joy, Research Nodal Officer, for his valuable presence and felicitation address. Thank you, sir. And I would also extend my sincere thanks to Dr. Shinto KG, IQAC Coordinator, for his felicitation address. And I am also thankful to all Program Advisory Committee members and invited speakers. And I express my thanks to Vice Principals, Bursar, all the research supervisors to valuable support for this conference. An event of this dimension cannot happen overnight. The wheels start rolling months in advance. We have been fortunate enough to be backed by a team of very motivated and dedicated Research Scholars Committee members, coordinators, and office executive members. I cannot thank everyone for this involvement they have shown and willingness they have expressed to take on the completion of tasks beyond their comfort zone. Thank you all, thank you very much. If time is money, then today you have spent millions for us. Thank to all of you for making this event successful. Once again, thank you very much.
We have now come to the end of inaugural session. Now we move on to our first keynote session by Dr. Manoj P. Samuel. Let me introduce Dr. Manoj P. Samuel, Member, Governing Body, Wetlands International South Asia. Dr. Manoj P. Samuel is the Executive Director of Center for Water Resources Development and Management, Kozhikode. The technologies developed and popularized by him include water filtration systems for different end users like drinking, irrigation, and groundwater recharge. Polythene line ponds for water harvesting and fish farming for hilly terrains, GA toolkit for groundwater management, water quality decision support system, expert system for technology evaluation, mobile fish vending kiosks, solar fish dryers, fish freshness sensor, and goes on. Dr. Samuel began his career at KVK ICA, Central Plantation Crops Research Institute, Kozhikode in 1995. Later, he worked as senior scientist in ICAR Research Complex for NEH region, Badapani and ICAR NAM, Hyderabad. In 2013, he was promoted as principal scientist at ICAR NAM, and during 2016-2021, he worked as head of division in ICAR Central Institute of Fisheries Technology, Kochi. He is a fellow of Institution of Engineers in India. Dr. Samuel has more than 150 publications to his credit, with 53 research papers in international and national peer-reviewed journals. He published 12 books, 33 book chapters, and 69 popular articles. He possesses 4 copyrights for computer software and decision support systems, 2 design registrations, and 2 patent applications has been filed. He is a member of 13 international and national professional societies and a reviewer of 19 national and international journals. He was also adjunct professor in College of Agriculture Engineering, Angaru, Bapatla member, Board of Studies, Vigyan University, Guntur, Andhra Pradesh, and academic coordinator of PG Diploma in Technology Management in Agriculture, offered jointly by the University of Hyderabad and ICAR NAM, Hyderabad, and also PG Diploma in Management offered by ICAR NAM, Hyderabad. He is a certified assessor for NABL, commercial expert of Agri Innovative India Limited, member of Transport Engineering Division Council and WRD Hydrometry Council of BIS. Working group member of National Institute of Hydrology, Roorkee, and evaluator of BIRAC, BIG, and GYTI projects. He is also currently serving as a management committee member of the KSCSTE Institute of Climate Change Studies, Kottayam, and Kerala School of Mathematics, Kozhikode. Sir, we all invite you for this keynote session.
Thank you. Thank you. Once again, good morning to all of you. In another 40 or 45 minutes, we will discuss something about, sustainable water management, climate change, and some of the climate smart technologies for livelihood and food security. And all our discussion starts from these days from the SDGs. You know what all are the SDGs? SDGs are Sustainable Development Goals. And there are 17 SDGs, and we have to attain these SDGs by 2030. That is the goal set by the global nations. And we all are actually striving hard to achieve these SDGs. And as a state, Kerala state is actually pioneering. We are actually front runners in achieving the SDGs. We are all proud about that. Especially SDG 6. 6 is very much connected to my institute. It is about water and sanitation for all by 2030. And of course, some other SDGs like SDG 13 is very important, climate action. Then SDGs 14, life underwater. SDGs 15, life on land. Then partnership, sustainable communities. So many other SDGs are also connected to, the science students like us. And I was mentioning in my inaugural speech, across the globe, the number of natural disasters are coming up. If you count from 1980s, if you count across the globe, you cannot find more than 200 events, whether it is a flood or a heat wave or wildfire or whatever it is. Climate-related disasters, maximum 200 or 250. But if you if you reach 2024, now the number of events across the globe has even reached more than 1,000 or 1,200. And it is going to increase. So that how we can stop it? And what are the strategies, what are the plans, what are the interventions we can take up to control the ill effects of climate change. And climate change is a reality. A few decades back, even people are actually really skeptical about the word climate change. Even now, the former President Trump is telling climate change is a hoax. But we cannot say that now, because in 2018, climate change reached up to our doorstep, and after that, maybe 2019, again the flood reoccurred. These type of things are happening, and in the future years also these things may happen. Now, the temperature of Kerala, on an average, it is around 36 to 38 degrees centigrade. And in February, we never witnessed this type of high temperature. We don't know, maybe in another 2-3 months, how the temperature rise will happen in our state, across India as well. So that, the temperature rise, the change in rainfall pattern, everything is happening. And previously, if you take our state as a whole, the average number of rainy days in Kerala was around 120 days in a year. But now, the total amount of rainfall is more or less same, but the number of rainy days have come down. It is around 90 or 95 days. What's the meaning? Same amount of rainfall is coming in less number of days. That means more intense rain, more heavy rains, unexpected rains. We call it cloud burst or whatever it is. Unexpected rain, very localized rain, we call ERE, extreme rainfall events are actually happening in a larger way. In a more number of these type of EREs are happening across our state as well as our country, or across the globe, you can say. You can generalize, there is no issue. And you can see this particular map of our country. And this is the map of all the districts in India in June. And there is an interesting thing in this graph. Normally, in June, the southwest monsoon starts. It starts from, it's
Hello. Yeah. So that the southwest monsoon starts in June, as all of you know. It normally starts from our state, Kerala. But this particular graph, the particular map of our country, you can see the places which is given in red actually is a deficit area, deficit amount of rainfall got in those districts, and yellow is again deficit, and blue are the heavy rainfall regions. Normally it should be opposite. In June month, it should be like a negative of the exact real June month figure. Normally in the June, where it is red, it should be blue, and where it is blue, it should be red. This time we got maximum rainfall during June in
states like Rajasthan, Gujarat, Himachal Pradesh, Uttarakhand and all. Normally they will not get that much rainfall during the month of June. Rather we get in West Coast and Northeast maximum amount of rainfall during the month of June. But this is just opposite in this June. We don't know what is going to happen in the next June or next southwest monsoon, next predominant monsoon period. So my point is, the climate is changing and we cannot predict it in a real sense because the pattern is getting changed in a bigger way. And for predicting the climate, we need what? We need data. Data is actually the basic thing for developing any prediction systems. But unfortunately, we don't have a reliable set of data because, around 20 or 30 years back, when we were children, we were of your age. Actually, in Kerala, we have hardly 10 or 15 rain gauges. Maybe one in Kozhikode, another maybe in Kannur, then Kozhikode. So that, these type of data is, very generalized data. For a larger area, we have only one rainfall or a meteorological station. And that data actually we are using for developing the early warning systems and prediction systems. And it may not be that much, precise, and that's why the corresponding prediction systems may not be that much accurate. So what we need now is actually we have to, now the rainfall pattern is actually is very much erratic. It is not at all centralized. It is a very much decentralized. In a same panchayat, one side you may be getting 10 centimeters of rainfall, other side you may not get even a single amount of rainfall. Last, northeast monsoon time, maybe in November, October, in somewhere near Iratipeta, in one panchayat, one side they got 10 centimeter rainfall, other side there was no rainfall. In Meenachal River, they have an agency called MRRA, Meenachal Rain and River Monitoring Agency. And the convener of that agency, Mr. Ebi, was telling me that happened in that panchayat. It is regularly happening in our areas also. The rainfall may be very much localized, and that's why unless otherwise we get, localized rainfall data, localized climate data, we cannot develop better prediction systems. Now we are asking all the panchayats to have at least a simple meteorological station, at least a rain gauge station in their panchayat, maybe one or two places in their panchayat, so that we will get lot of data in future. A large, a group of data we may get in the future, and this data will be useful for developing better prediction systems for maybe after 1 or 2 decades, and it will be much helpful. And what will happen? IPCC, what is IPCC? IPCC is the agency which is coordinating all the climate change related studies, and it is giving, the predictions and the strategy advices, all IPCC is giving. What is IPCC? International Panel for Climate Change. And we are also part of that panel. And IPCC, in regular intervals, they actually publish a report. They called assessment report. 2 years back, assessment report 6, AR6 report has come up. As per AR6 report, if the temperature goes, 1.5 degree, above 1.5 degree threshold, the number of extreme events may go up to 7 times. If it is 1 flood in an year here, maybe in future it may be 7 floods. So we have to stop the global temperature rise in one way or other. Let's say what are the strategies we will be looking towards. And in future years, I think naturally the global temperature will go up. What are the causes of global warming? Global warming, how it happens? Yeah, global warming happens in many ways, but the major cause, the major reason is me and you, because we are emitting a lot of amount of carbon dioxide and other greenhouse gases to the atmosphere. What are the other greenhouse gases? Carbon dioxide, methane, nitrous oxide, then hydrofluorochlorocarbons. Actually, carbon dioxide is not that much, it's a very, very severe type of global warming system. Global warming, it creates a lot of global warming. But the amount of carbon dioxide is so huge, so that the triggering effect is more. For example, this hydrofluorochlorocarbons, CFCs or HCFCs, that the triggering effect is more for these type of gases, but the amount is very less. That's why actually we usually neglect these things. We normally call it as carbon emission, because carbon dioxide is coming in a huge amount, and such a big volume of carbon dioxide creates a lot of issues. Why? All these greenhouse gases actually after our, maybe in our earth crust, or just after the earth crust or in the earth atmosphere, it creates a layer of greenhouse gases. And normally the solar radiation which is reflecting back are getting entrapped in this, concentrated layer of greenhouse gases. Naturally, it increases the temperature of atmosphere, and naturally the crust of earth. And that is we call global warming. And yet small changes in the temperature naturally, affect the climate. It may affect the rainfall pattern, the temperature, the huge, the increase in temperature may melt our glaciers, sea level may rise. Some of the rivers, maybe in the summer season, floods may happen. Normally in Bihar, Kosi river you might have heard, the floods regularly happens in every year, but normally it happens on the top of on the peak of the summer months, because during the summer months more melting may happen, more glaciers may melt, naturally more water will flow in the in the river, and it may lead to flood type of situation. So my point here is actually, these type of things are happening. It may happen in a more high intensity in the future, so that what we can do, so that the future years are not very much rosy, but we can do something. There are two ways, as I told in the beginning. We can take up two strategies. One is mitigation strategies, second is adaptation strategies. Adaptation strategies we also call resilience strategies. Mitigation means how we can combat climate change, how we can reduce climate change in the future, so that we have to reduce carbon emission. Not only the carbon, methane, nitrous oxide, all these HCFCs, CFCs, emission we have to reduce. That's why, the global community is thinking about the better fuel systems, better, electricity generation systems, better fuel, better vehicles, electric vehicles, hydrogen vehicles, solar systems, so that, emission may be reduced. In NCR region, normally every November month, normally they have an issue. They call it smog. What is smog? Yeah, smoke plus fog. From where this smoke is coming? Because from Haryana, Punjab region, the farmers, after their first crop, they burn their agricultural residues. It's basically to prepare the field for the next crop. Normally, around 40% of the farmers, first crop they will take the rice, and second crop they will go for the wheat. And normally there are two issues with this. Normally they cultivate a rice variety called Pusa 55. It is developed by Indian Agriculture Research Institute under ICAR. This variety is very good. It actually the production is very high. But the issue is actually this long duration variety, around 140 to 155 days it will take. So that the farmers will not get much interval for preparing the land. They have to actually do the harvesting. Maybe within 10 or 14 days they have to prepare the land, plow the land for the next crop. Mostly it is wheat. So that the easy way is to burn the residues. Now the same Indian Agriculture Research Institute, they developed a chemical, their chemistry division, agriculture chemicals division, they developed a chemical. It's called Pusa decomposer. So that if you spray this this liquid to the agriculture residue, it will decompose it. But it will take, of course, it will take 20 to 21 days, 20 to 25 days. But again, there's an issue. Farmers are actually not ready to pay money for purchasing this sprayer, that means purchasing the sprayer as well as this chemical and spray to the residues. Rather, they can just burn it so that it is very easy for them. And it is an easy way also. Within 1 or 2 days, they can prepare their field. So that here there are 2 strategies we can adopt. Actually, government is seriously thinking about it. Niti Aayog is thinking about it. One strategy is actually with a long-term view. We are also part of that thinking process. It is about, the Niti Aayog is thinking about developing a framework. Firstly, they will introduce in 2 states. One is in Punjab, another in Gujarat. What is that? In a farm gate, within the farm itself, the farmers can mark their agricultural activities in a mobile app. So that we are developing a framework. So that if somebody is going for a particular crop, whether it is a rice or wheat or whatever it is, vegetable or whatever it is, every activity from the first day itself, they have to put it in that smartphone. So the first day, what activity they have done, they will be actually recording here. So at all the activities, they will be recording in a chronological way. And apart from this, the resources in the field, whether it is water resources, what fertilizer they are giving, what are the other agricultural inputs they are giving, everything is actually recorded. Everything about your agriculture, everything about your farm will be recorded in this smartphone, in this mobile app. And finally, at the end of the day, after you harvest, when your product went out of your farm gate, it will be calculated, the algorithm will work, the computation formula will work, and finally it will give you how much carbon credit you earned. You are getting a positive credit or a negative credit. If you are actually saving carbon, if you are going, that means if you are actually, your emission is less than your sequestration, you are reducing your emission, you will get positive carbon points. And this will convert it into money and it will come to your bank account. It's a revolutionary idea. So that if people will be, now actually people are not ready to pay 1,500 rupees and purchasing the, Pusa decomposer, because they can easily burn the agricultural residues. Rather, if they are going for this natural way of decomposing, they can earn positive points. So that 5,000 rupees will come to their pocket. They can spend 1,500 or 2,005 rupees for this, natural way of decomposing instead of burning. So these type of things has to come. Farmers has to be motivated. That is one way. The second way actually government is thinking is to introduce a short variety paddy. Instead of that Pusa 55, we will now go for the Pusa Institute itself is working to develop a shorter variety paddy. So it will be the entire cropping pattern, cropping process will continue complete in 120 or 130 days. So that farmers will get a buffer time. They will get around 20-25 days to prepare their field so that they can go for the composting or any other type of natural way of decomposing the agricultural residues. So these 2 ways government is seriously thinking so that the issues in Delhi can be, reduced up to some extent. Otherwise, Delhi is not at all a livable city now because there is no air, no pure oxygen now in the city, especially in some time periods in the calendar year. So what is my point is here, the climate change is affecting us in different ways and we are also going to be affected in a bigger way in the future days to come. So how best we can control this, what are the mitigation strategies, and even though we have to live along with the climate change, so that how we can adapt ourselves, how we can develop the resilient strategies, how we can go for the the adaptation strategies. These things actually will take a major role in the future. And yeah, so this is the precipitation events. Yeah, as I told in the previous slide, the number of heavy rainfall events are going up in Kerala. You can see the light to moderate rainfall events are actually coming down, 5 to 100 millimeter. But the heavy rainfall events, more than 10 centimeter or 100 millimeter, it is going up. You can see the trend. This is actually from 1950 to 2000. Now if you have taken another 20 years up to 2023, the trend is more visible these days. And the heavy rainfall events is actually a reality. It is actually happening. And the number of heavy rainfall events are actually going up across the globe. It is more evident in our state. And again, climate change impact, the impact is actually we are directly dealing with many impacts. Apart from that, we have indirect impacts too. One is agriculture. Because the climate change affects agriculture in a larger way. Especially you can see if the increase in temperature is up to 2 degrees centigrade that we are expecting by the end of this century, the corresponding decrease in agriculture production is almost 0.75 ton per hectare. You cannot even think about that. 750 kilogram per hectare reduction in the food grain production if the temperature rise up to 2 degrees centigrade. This is about wheat. It actually the statistics may change, depends upon the place and depends upon the management strategies and everything. But whatever it is there, the climate change is also affecting the way we do the agriculture, negatively affecting. And as far as India is concerned, our total water availability is 1123 billion cubic meter in an year, including the surface as well as the groundwater. Our total water availability is 1123 billion cubic meter. You know what is a billion? 100 crore. 1 cubic meter means how many liters? 1000 liters. So that, if you multiply it together, you will know how much large amount of water we have. In Kerala, you know how much rainfall we are getting? What is our average annual rainfall? Our average annual rainfall is 3000 millimeter. It is 3 meter or 300 centimeter, whatever the unit you say. But what is that? Yesterday we got 10 centimeter rainfall in the Christ College campus. Means how you can visualize it. Ten centimeter rainfall in Christ campus means, you just imagine the water which is falling from the sky in our campus is actually not getting lost in any way. There is no evaporation, no percolation, no seepage. If water is actually stagnated here itself, 10 centimeter height, water will be stagnated. So that Kerala total we are getting 3000 millimeter rainfall, 3 meter. So that the entire water which is coming to Kerala in an year, if it is not going anywhere, the Kerala will be filled with water up to a height of 3 meter. In Cherrapunji, I worked in Meghalaya for 5 years. I was in Shillong. Cherrapunji is very nearby. Cherrapunji, you might have heard, it is the wettest place on the surface of earth. The average annual rainfall of Cherrapunji is 1200 millimeter rain 1200 millimeter. That means around 12,000 millimeter. That means 1200 centimeter rainfall. That means the entire water which is coming to Cherrapunji, if it is allowed to stay back there itself, Cherrapunji will be filled with the water up to a height of 12 meter. Such huge amount of water. But still Cherrapunji is a drought prone area. It's a drought prone area. Why? There are many reasons. Like our state, Cherrapunji is actually, it's on the top of a cliff. The Cherrapunji is a beautiful place. If you go to northeast anytime, please do visit Cherrapunji as well. It's a very beautiful place. But if you go to Cherrapunji, sometimes you feel very bad because the entire forest has been gone. Because normally in northeast they used to cultivate in a particular fashion, and it is called zoom cultivation or shifting cultivation. They remove forest in a particular area, they start cultivating there because the land belongs to the community, not an individual. So that they remove the forest, cultivate it for 1 or 2 seasons. Once the fertilizer status goes down, they will move to the next place. And what will happen to the first land? After 1 or 2 seasons, the entire soil will be lost because of the heavy rainfall and the topography of the land. The land is highly slopey. And after that, you can see only, some barren lands, bare hills you can see. And another major issue in Cherrapunji is actually, the one of the commercial activity in Cherrapunji in northeast is, limestone mining as well as coal mining. So that if you go to Cherrapunji, if you can see in the hillocks, you can see lot of small holes. And if you again look towards the holes, 5 minutes, if you look towards the hole, you can see some small boys will be coming out of the hole. These small boys will be going inside the holes, and they will be actually carving out the limestone, as well as they call rat miners. Recently in Uttarakhand, there was an issue. Some people actually got entrapped in the tunnel. The rat miners went inside, and they removed the debris, and finally they were saved, right? The same way you can see in the northeast, in the mining areas, the small boys they are actually crawling inside the hillocks through the tunnels, and they are actually that means taking out the limestone as well as the coal. And finally what happens, this entire Cherrapunji area is actually connected with a network of tunnels. Whenever the rainfall happens, the entire rainfall which will be going down, much down, thousands of feet down to the Bangladesh by these channels of tunnels. And what happens finally, Cherrapunji is a drought area and Bangladesh is a flood affected area. Every year this happens. So at my point again back to here. So that here in Kerala we are getting 3,000 millimeters of rainfall, and we are getting 3 meter height of rainfall every year in Kerala. In a hectare, how much rainfall we are getting? How much liters? 1 hectare is how many square meter? 10,000 square meter. 100 meter, if you just take a square area, 1,000 meter length, 1,000 meter width, the area is 1 hectare, 10,000 square meter. 10,000 square meter, you are getting how many millimeters of rainfall? 3,000 millimeter or 3 meter. So what is the total volume? Area into depth or height. Again mathematics, right? Again, so the total volume is 10,000 into 3. That means 3,000 cubic meter rainfall we are getting, 3,000 cubic meter water we are getting in each hectare of land in Kerala. Again, what is cubic meter? 1 cubic meter means how many liters? I told just now, 1,000. That means 1 meter length, 1 meter height, 1 meter depth. Sorry, 1 meter length, 1 meter width, 1 meter depth. You make a hole, you make a hole and fill water. 1,000 liters you can fill in that. So that 30,000 cubic meters of water you are getting in 1 hectare of land in Kerala means 30,000 into 1,000. 3 crores liters of water you are getting in 1 hectare of land. How many acres are 1 hectare? 2.5. So that 1.25, almost 1.25 crores of liters water you are getting in 1 acre of land in Kerala. My point is such a huge amount, no? Because 1 liter, if you count 10 rupees, you are actually 10 or 15 rupees you are paying for 1 liter of water. So how much huge amount of water if it is calculated as per monetary terms. But anyway, we'll come back to our subject. So in India, total water availability is 1123 billion cubic meter. That is the total water availability. Supply. Demand is now around 850 billion cubic meter. So that now anyway the demand is less than the supply. There is no issue. But as per this projection, you can go to see the screen. As per one of the projection, by 2050, the water demand is going to rise up to 1450 billion cubic meter. And we have only 1123 billion cubic meter. So that from where the extra water will come? There are 2 ways to tackle this situation. One is to increase the supply. But increase the supply is easy or not? Whether we can increase the supply, whether we can create the water, it's not at all possible. But there are some ways. One is of course rainwater harvesting. The water which is coming on our roofs, which is coming in our nearby areas, it can be collected. It can be collected in line ponds. It can be collected in a ferrocement tank or syntax tank, and it can be utilized. So that through rainwater harvesting, groundwater recharge, actually we can enrich our aquifers, right? Geology students are here. So these ways we can actually increase the supply up to some extent, maybe 0.5% or to 1% we can increase the supply. Then another way is, another very good way is to increase the supply. Can you suggest anybody? That is, in Singapore, you know, out of the total water use, 30% of the water they called new water. Why they call it is new water? It is recycled water. Reduce, reuse, recharge, recycle we call. This is actually recycled, the water which is coming from the, you know, your kitchen, your bathrooms. May not be from your toilets, maybe from your bathrooms, your wash sinks or your kitchens. It can be purified, it can be recirculated, it can be reused. It may not be used for drinking water purposes. All other purposes it can be used. Recently we signed an MOU with the Confident Group. And it is, you know, in Confident Group now they have 2 piping systems. That means the sewage line. The water from the bathrooms, water from the kitchen, water from, you know, your wash basin, it will be pooled together and it will go to a purification system. Water from your toilet, your laboratory and all these things will go to another directly to your septic tank. But the first type of water will be purified back, and this water will be you know, recycled and purified back to a minimum standard quality good water, and this water will be again utilized for, again, you know, the flushing we can use the same water. Washing your car you can use, for your kitchen garden you can use the new water. So that through recycling we can actually generate a lot of amount of water. But unfortunately in India, less than 1% of the water is actually really getting reused. But in Singapore it is 30%. So there are 2 ways to increase the supply. One is, you know, rainwater harvesting, groundwater recharge, and of course through recharge. But the easy way is to reduce the demand. Either we can increase the supply or reduce the demand. There are 2 ways to manage the water problems in the future. But reducing the demand is not very easy, but comparatively easy. In India, most of the commodities we are using more amount of water. Can you suggest how much amount of water this shirt, for producing this shirt, it is used? How much amount of water? In India it is 18,000 liters. 18,000 liters of water I am wearing now. That means the cotton cultivation, then harvesting, all the processing, ginning, then dyeing, stitching. All the processes took almost 18,000 liters. That is India's average, but the global average is only 8,500 liters. That means in India we are using 10,000 liters of extra water for producing one shirt. Similarly, 1 cup of coffee if you are drinking, you are using around 65 or 75 liters of water. 1 kg of rice, the water footprint, we call it is water footprint. Water footprint is the water required for producing 1 unit of finished product, 1 kg or 1 packet of finished product. So that the water footprint of most of the commodities in India is so high, we are using extra water for producing everything. So that we can reduce water usage while producing, by cultivating, by producing, that means industry or wherever it is in the factory, we can reduce water. That is one way of reducing the demand. And a similar terminology is there in carbon also. Nowadays the global community is thinking about carbon footprint. If you have a finished product with a less carbon footprint, there are more buyers in the global market. They are ready to pay premium price. Recently I had a conversation with Mr. Alex Nine, and he is the president of Seafood Exporters Association, and he was telling, now if you can if you can actually pack 1 kg of marinated shrimp with less carbon emission, it will be actually marked on the packet, in the outside the packet, like FSSAI, so many things, green, so many actually. In that actually nowadays European countries, Japan, US, they are asking to also record how much carbon is emitted for producing that 1 kg of finished product. That means during harvesting, your processing, your packaging, how much emission happen. So that if you can produce the same amount, same quality or same amount of finished product with less emission, you are going to fetch better prices in the market. So naturally the industries will be attracted towards that, right? So like organic, maybe the same banana, if it is organic, we are ready to pay 20 rupees extra for kilo or 50 rupees extra for kilo. Same way, the same product. But if you are actually using less carbon for producing that, the global market is now ready to pay premium price for that. So that is like a carbon footprint, water footprint. Again, we are back to water footprint. So that my point here is actually we can reduce the demand of water. That you can see in the next picture here. You can see on the right side in the circle. It's a comparison between three countries. One is Israel, one is India, another is China. It is actually, you can see, it is actually agricultural GDP per cubic liter of fresh water withdrawn for agriculture. That is a ratio. In Israel it is 4, India it is 0.4, China it is 1. What is the meaning of that? With the same amount of water, Israel is producing 10 times more food grains, more fruits, more vegetables compared to India. With the same amount of water. And China, which is having more or less same demographic characteristics of India, it is producing 2.5 times more food grains and vegetables compared to India. What is the meaning? We are using extra water, more water for all the purposes including agriculture. So that reducing the demand is one of the major focus in the future. So that we have to increase the water productivity, irrigation efficiency or water use efficiency. Similarly, groundwater also. You cannot believe UNESCO's statistics. The total groundwater extracted by both the giants together, America and China together, it is only 25% of India's groundwater extraction. So do you see how huge quantity of groundwater we are extracting from the aquifers? We can use the water, groundwater, there is no issue, but we should recharge it. We should judiciously use the groundwater because it's a reserve kept for our future generation as well. So these are all the issues we are facing, myself and you are facing. I'm not going into the details of each and everything, but still I will read that the major issues: climate change impact, recurring floods and droughts, increasing emission of greenhouse gases, water security, quality, equity. Equity is also very important. We are actually, our government is supposed to give equal and good quantity of water, good quantity and quality of water for all sectors in the community, right? Marginalized people, gender, means aged people, everybody has to get good amount of water with good quality. So that equity is also very important. Then change in water use and land use pattern. In Kerala it is very dynamic. And again, fragile ecosystems, river management. Kerala we have 44 rivers we call. Actually all the water courses more than 15 kilometers of length we call river in Kerala. But the total water flow of entire, all the 44 rivers, if you sum up, it is not equal to a Godavari or a Mahanadi. So that, of course, this chain of rivers actually helps Kerala to distribute water resources in a better way across the communities and across the landscapes. But still, the management of rivers is very important because in a river, we have many agencies, many people with a conflicting interest, right? The interest of agriculture department will be different from fisheries. The same thing is happening in Kuttanad. That is different from tourism. It is all maybe different from the water authority, drinking water. So that how we can manage the conflicting interest in a similar water course. So that these all are the things to be, discussed further in the future years to come. Again, environmental issues. Of course, agriculture, automation system, these all are not threats, rather these are the opportunities. How we can integrate artificial intelligence, precision agriculture, machine learning, hierarchical systems, all these things to agriculture so that we can reduce the demand and we can improve the productivity. Similarly, the climate change is impacting all walks of life. It is not only the, the disasters or agriculture or something like that. It also, affect your health. Recently, Landsat has a report, Landsat countdown on health and climate, I think. So that, and in this report it is mentioned that, in India itself, around 168 million labor days have been gone because of the extreme climate. People cannot go out and do the work. It is almost equal to 5.4% of India's GDP. Because of heavy temperature or high rainfall event, labor force cannot go to the field and do the work in the open field. So that they are losing their livelihood, their earnings. They are losing, actually the country is losing the manpower, man days. That is one way. Similarly, health. All the health issues are one way or other connected to the climate. Now we are discussing about the One Health approach. recent, the theme of recent Kerala Science Congress also was One Health approach. The health of myself, health of health of you, the health of your animal, health of your pets, health of the birds, fish. Everything is actually interconnected, one health approach. So that, climate change is connected to everything. Climate change is connected to the gender also. Recent one study we read, whether it is a flood, whether it is a drought, or whatever it is, the women, the gender, the women part is actually suffering most, because they are actually walking miles to fetch water. The same time in the flood time, they are actually facing much problem for managing their issues. So that these type of things actually nowadays, recently Kila has actually organized a program with the Tata Institute of Social Science. Last week I have read their proceedings. It was basically on climate change and gender, how gender is affected to the climate change. And recently, one study, you can see the public health, one interesting study. Studies are coming in different ways. As a scientist, we have to think laterally. We have to think in a different ways. Out of the box, we have to have thinking, right? So that one thinking, you can see how the climate change is affecting the women health, the retardation in our girls. As per that study, when a flood situation happens or when a drought situation happens, normally girls are actually more affected indirectly. How? They are telling in a normal condition, the boys are actually more subjected to retardation. If you are giving the same amount of food without much nutrition, actually because boys have more, physical activity, and if they don't get enough nutritious food, naturally they will go for retardation. But in a flood time, this is just ulta, it is just opposite. Not boys, but girls are more subjected to retardation. And their reasoning is that in a flood time, the supply is less. We are not getting enough water, we are not getting enough food grains, we are not getting enough food. So that the parents have a natural tendency to feed their boys more compared to the girls. May not be the case in Kerala, I don't know. But in other places it may be true. So that they are telling in a flood situation or in a drought situation, girls are actually more subjected to retardation. So that this is, you can see the public health, the reference is given there. Dimitrova 2019, I can give you the entire paper if any of you are interested. So that the social science is also very much, the health is very much involved, the social science is involved, the agriculture sector is involved, fish sector is involved to the climate change. The same, the same graph I have shown earlier also, how the temperature, extreme rainfall events are happening. This is for Bharatapuzha. You can see from 2000 to 2020 how the rainfall is increasing, especially extreme rainfall events are increasing in the Bharatapuzha river basin. And you can see here the Bharatapuzha river basin, as per one of our studies, 65% of the command in Bharatapuzha area, the Bharatapuzha catchment area, is affected with one or other type of drought condition. Why drought is happening? We can easily attribute everything to the climate change, right? But it is not only because of climate change. There are anthropogenic reasons as well. You have environmental science students also here. So you can see here, it's a map of Bharatapuzha from 1998 to recent years. So you can see the yellow area is actually the paddy areas, green is plantations, and red is built up area. You can see how the yellow is changing to green and green is changing to red. So that now the anthropogenic reasons, the development, of course development has to happen, but development in cost of the environment, it is creating issues. It is triggering the climate change, right? So that climate change is only one reason, but apart from that, increase in water demand, land use changes, human interventions, and finally, very importantly, absence of local measures that might build climate resilience. That is very important. As I told in the beginning, we should have local data, localized the climate data we should have. Based on that, we should develop the prediction systems, strategies, and the package of practices or the mitigation strategies or the contingency plan, which we develop for a panchayat may be different from the other panchayat. So that we should have localized planning processes in the future, so that we can tackle the climate change in a better way. So that I was telling about the demand and supply in the previous slide. Apart from the demand and supply, the water sector has other few perspectives as well. So that one is of course the quality and quantity. Around 1 or 2 decades back, we are not much bothered about the quality. But now we have an NABL accredited lab in our campus at Calicut, and previously we hardly get around some 2,000 or 2,500 before COVID, 2,500 samples in a year from from the hoteliers, from the general public, farmers. But now last year we got almost 7,500 samples. This year I think it will cross. So that many people are actually bothered about the quality. Different parts in our state are actually facing different issues of water quality issues, whether it's a bacterial contamination or chemical contamination. So water quantity as well as quality both are important. Similarly, deficit and excess. Maybe in the same space, in the spatial scale, maybe in the same locality, it may face different issues in the same calendar year, right? One month it may be excess, another month it may be deficit. Maybe in the same temporal scale, different spatial, maybe in the upstream and downstream, we may face both extreme and excess and deficit. So these things we have to manage. We should develop strategies based on all these things: quantity, quality, deficit, excess, and demand and supply. But of course, blue, green, grey water management is also very important. How blue water can be converted into green water. Actually, blue water is the water which we can see with our eyes in our water bodies. Green water is the water available in the soil which can be absorbed by the plants. And grey water, you know what it is, that how the grey water can be purified and recycled. A lot of, out of the box thinking, new ideas are coming these days. I will read some of the things. I will not explain all the things. Room for river. Our Chief Minister is actually speaking more about that, because Netherlands is a country, actually it is actually surrounded by canals and a lot of water bodies. Last floods in 2018 and 19 floods, one of the major issues we faced is actually there was no room for the river to flow, because half of the river is either encroached or it is actually maybe blocked because of sedimentation and many other issues. So the water has to get a room for flowing, room for river, fuse, flood forecasting and early warning systems, accurate weather forecasting and nowcasting systems, landslide mapping and prediction. Again, now we got a DST supporter project we are running with NIT Soratkal. It is basically, predicting landslide a few minutes back, at least a few minutes before. At least we can save the lives. So that we are actually finding out the, the pore pressure, then, 3 parameters actually we are finding out. So that we developed an algorithm. We are actually developing an algorithm so that by integrating the climate parameters as well as the soil parameters together, we can predict whether that area is prone to landslide. And of course, it is actually connected to the nowcasting system based on the current rainfall. So immediately it will trigger, maybe there's a possibility of landslide in this particular area. People has to be evacuated as fast as possible. So that now we are working on that. It is basically a mobile app, a warning system. Then groundwater recharge, disaster risk management systems, coastal reservoir is a new concept. Then precision farming, micro irrigation, grey water recycle, reuse, irrigation scheduling, pollution tracking, mapping, prevention, water budgeting, demand assessment, distribution, multiple and conjunctive use of surface and groundwater, carbon neutral and climate resilient villages and all. A few things I will be explaining in the coming slides, and I will finish it off. So that water, energy, greenhouse gases, everything is in an excess. You cannot study or you cannot speak about any one thing. Water is connected to energy, because for example, you need more water. What you will do? You pump more water from your wells. If you pump more water from more depth, what will happen? More emission, it may happen. When more emission happens, it will lead to global warming. The global warming will affect your rain. The change in rainfall pattern will actually lead to water deficit or excess. So that accordingly the pumping pattern also will change. So that everything is actually connected with each other. When we think about water management, actually 6 areas you have to think about. One is supply, demand, I told already. Then water governance and policy. That is also very important. In the days to come, we will be thinking more about the governance, how the water can be equally distributed among different communities, different parts, upstairs and downstream people together. Again, capacity building. Then disaster management and climate resilience. Water budgeting, this is a new scheme under Harita Kerala mission, Government of Kerala has introduced, and we are giving the technical support this program. What is this? Under this scheme, now we are developing a document. It is called water document, water budget in all panchayats in Kerala. Actually, we are targeting block panchayats. What we are making? What is the total amount of water available in that particular area by means of rainfall, by means of surface water, by means of groundwater, by means of export from other places, water is flowing to our panchayat, and how much water is going out from our panchayat through canals or some other things. So what is the total supply, availability of water in our micro area? Same time, what is the total water demand in our panchayat? Water demand in agriculture. How many coconut trees are there? How many rubber plantation is there? How many paddy areas are there? What is the crop water requirement? Accordingly, we can calculate. Different season, what is the crop water requirement? Similarly, for industry, for drinking water, for tourism. So that we will weigh both the things. What is the supply? What is the demand? And these things for different scenarios, different seasons, we will calculate and we will make a document. We will also keep the future scenarios in view of the climate change. And this document will be helpful for the panchayats to plan their activities in the primary sector, activities in agriculture, animal husbandry, or any primary sector. This document will be supportive to them. And nowadays we are actually adding another dimension to that. What is that? We are actually mapping some of the panchayats for carbon neutrality. What is the total emission from that particular area, from different sectors, from energy sector, from transportation sector, from pollution, from afflu, agriculture, forestry and other land uses, animal husbandry, everything together. So what is the total emission from each sector, where the emission is happening more? Those all are the hotspots. We have to constantly look towards that. Why more emission is happening? How we can tackle it? So that we can, where more emission is happening through transportation, now we can encourage the people to go for pooling of vehicles, go for the EVs, electric vehicles. And energy, more emission is happening, we can tell them, don't use, the conventional energy, rather you go for the renewable energy, solar systems, roof solar system or whatever it is. And wherever sequestration is less, similarly we will also measure the sequestration. What is the absorption of carbon happening in different parts of the panchayat? So that maybe absorption is less in one part, we can actually go for Miyawaki forest or develop a water body. This carbon emission, how we can control? One way, European nation, what they are doing? They are actually making bigger sinks, almost 800 meters, 1 kilometer down under the soil, under the earth. They make a big repository, a tunnel like of things much under the soil, and they capture the carbon dioxide from the atmosphere and put them inside in the deeper, soil. That way they are removing the carbon dioxide. But it's a very, very expensive process. So what India like a country we can do, we can promote sequestration by means of, protecting our forest, protecting our ocean. Ocean is one of the sink which almost sequestrate 25% of our carbon dioxide. But another few decades, there will be more plastic in ocean than fishes, right? So that ocean is actually deteriorating one side. So that our sinks are actually one or other side actually getting damaged or destroyed. So that all are the issues in the future. So in this water budgeting, we will be making this document, and this document will be helpful for the panchayat to strategize how they can reduce the emission, how they can reduce water footprint, how they can save water, and how effectively they can distribute water among different users. Same time they can reduce emission as well as increase the sequestration potential, and slowly elevate their panchayat to a carbon neutral or net zero LSGD. And recently we released a book. It is called Rains and Rivers of Kerala. So that the entire water resources in Kerala is actually documented here. How much water we are getting by means of rainfall, surface water, how many water is available in our rivers, how much groundwater we have. So this is actually a ready reckoner. Everything is available in this 10 or 15 pages booklet. And a few examples I will say, about water management. So one of the promising technology for managing water, reducing the demand is precision agriculture. As the name implies, it is about precision. What is the exact amount of water a crop requires, that we will find out. Accordingly, water will be supplied. So we are using different resources here. We are actually using satellite images, we are using sensors, we are using the soil parameters, all the things we are using, all the data we are using, all the information we will pull together, and we will find out a solution, how much water is required, and accordingly it will be given. I will be giving some examples. All are real-time examples I came across personally with all these people. That's why I'm showing here. You can see the down one. It's called Gramworks. You can Google it and see. It is GRAMWORX, Gramworks. This company, when I was in Hyderabad, I was in National Academy of Agriculture Research Management for 5 years, a few years back. When we have a TBI there, Technology Business Incubation. So one fine morning, one person has come. He's a NRI. He was an NRI. He came back to India and he wanted to start a new startup company in India. And his leaning is towards the farming community. He wanted to do something for the farming community. He's from Andhra. His name is Gopalakrishnan. So that he was asking us to give an idea for his startup company. So that we were discussing, and finally we told, why don't you start a irrigation scheduling company? What is irrigation scheduling? Irrigation scheduling, we are giving how much, we are actually finding out how much water a crop requires at a particular day, particular time, maybe a second, maybe a minute. How much water that particular crop required in a particular time, particular place, particular soil. That we will find out, and accordingly that water will be supplied. So here what we do is, what we have done is, actually irrigation scheduling is not a new thing. Previously what we do is, actually we will find out how much water a crop requires. A coconut tree requires how much water in a day? 50 liters a coconut tree requires on an average. So previously what we do, we take a timer. If you go to Coimbatore, you will get some 500 rupees, you will get a kit. So that you can put in a timer morning, and normally we give by drip irrigation or something. So the water can be exactly, it can be given. So that normally for a coconut tree we give 8 liters for drippers. So that in an hour it will go 32 liters will go to the soil. So that if you purchase this timer, around 1.5 hours it has to work in a day, or 2 hours. So the morning 1 hour, evening 1 hour, we will put the timer, and accordingly solenoid valve will open and it will work. It was simple. But again, the problem is, it is just on assumption. We assumed that, based on some calculation, we assumed 50 liters a coconut tree requires, and accordingly we supplied water maybe together or 2 times or 3 times in a day. That's fine. But next level what we have gone is, actually we put the sensors in the soil. We put traditional sensors like soil moisture sensors, tensiometers in the soil. Now better sensors are coming. Now we have capacitance, or better sensors are available now. So these sensors, what will do, they will sense the availability of water in the soil, and accordingly water will be given. How they will sense? Actually, in the soil there are pores. When we are irrigating, all the pores will be filled with water, and after some time some water will drain off due to gravitational force. Then after that, all the macro pores will be drained off, but micro pores will be filled with water. That particular stage is called what? All the micro pores are filled with water. After irrigation, maybe after irrigation you gave water, maybe 10 or 15 minutes you wait. After that, all the water will be drained off, percolation will happen. Then the remaining water, all the micropores are filled with water. That particular stage is called field capacity. Field capacity is the stage where the plants can easily absorb water, because water is everywhere. All the micropores have got water. Then maybe 1 day, 2 day, 3 day, 4 day you are not irrigating, there is no rain. The water in the micropores will go, because mainly due to evaporation. Some water the plants will take. Then maybe at the end of the 4 days, there will not be any water in the micropores. Maybe some hygroscopic water will be there, that is no longer available to the plants. So that particular stage is called what? Wilting point, because there is no water, then plants will start wilting. So that there is the water availability, this is field capacity, all the pores are filled with water. This is the stage where there is no water available. This is the stage water is available to the plant. This is the phase. So what we do in irrigation scheduling, when the field capacity is reaching its 50%, that means half of the water in the micropores already lost. When field capacity reached its 50%, irrigation will start. That we call management allowed depletion, MAD. So that we know for each type of crop, each type of soil, what is the field capacity we know. Field capacity for clay, field capacity for sand, field capacity for loam, it's available. So that we know the field capacity, and using the sensors we can find out the moisture content. So that when the moisture content reaches 50% of the field capacity, automatically signal will go to the solenoid valve. Solenoid valve is an electronic valve. When the current goes, it opens, so that it will work. Water will go to the root zone of the plant or to the crop. That way it will work. So that is the second advanced stage for irrigation scheduling. Here it is better than the timer, right? Because the timer was just an assumption, but here at least the real time soil moisture content we are measuring, and accordingly we are irrigating. But again there is an issue. What is the issue? You are now looking only towards the crop. No, you are looking towards the soil only. In the same soil you have a coconut tree, but you have a brinjal plant also. You think both require same amount of water? No. So that a water requirement of the crop, what is called water requirement of the crop? Another word of water requirement of the crop is ET, evapotranspiration. A crop requires water for two purposes. Basically for transpiration. But apart from that, the crop's leaf and the surrounding of the crop loses water through evaporation. 99% of the water goes through evaporation, 1% only they requires for transpiration purposes. But together we call ET. Evapotranspiration is the water requirement of the crop. For coconut, the basin area is big area, so that entire area you have to see the evaporation losses. Okay, so that when this globalization come, we told him to develop a irrigation scheduling system based on the ET. ET we don't have any sensor. Of course, some satellite sensors are there, but it's not very accurate and it's very expensive as well. So that what he had done, if you go and take his mobile, take the service of his company, his team will come and install a automatic weather station in your field, AWS, and you can download this mobile application also. And nowadays AWS is not very much costly. It may be 25,000, 30,000. You can get an AWS. That's why we are telling now Panchayat presidents, just to purchase an AWS, maybe 50,000 rupees, and get the data. How much rainfall and how much climatic parameters are actually varying in your Panchayat. And this data will be useful not for you, maybe for next generation of the people. This data sources will be helpful for developing better prediction system for your Panchayat in the future. And many Panchayat people are actually now doing that. They are keeping some money for developing their database, especially climate database. Of course, that is secondary thing. So here what they do, this Gramworks team will come and install a automatic weather station. And automatic weather station will give you the climate data. And entire data he will put into an equation called the Penman-Mondiath equation. There are different equations to find out the evapotranspiration. But one of the best equation is, empirical equation is this Penman-Mondiath equation. Input parameters of this equation is basically what is the temperature, rainfall, radiations and all these things. So that you will get what is the ET. And evapotranspiration is the water requirement. Of course, the crop coefficient and everything, multiplication, everything will happen, because when we set the software, we will also put what is the type of soil, what type of crop they are doing and everything. So ultimately, when you are using this particular mobile app, it will actually find out what is the exact amount of water required by each crop in your field at a particular time or a particular soil. The water requirement in that area, water requirement in this part may be totally different sometimes. So that will be found out and it will be given by electronic systems. So that for managing your field, you don't require anybody at all. Maybe a caretaker is required for closing the gate and to avoid the trespassers and all. Otherwise, it is totally mechanical, totally system controlled. And he is telling when he started the system, he started a company hardly 5 or 6 customers were there. Now his customers, number of customers have gone up to 10,000 or even plus. You cannot believe. You can see how many downloads. You can see when you go to Google Play, you can see the number of downloads of his mobile app. Of course, you have to pay some subscription fees. And he is telling, interestingly, most of his customers, not most, many of the customers are actually, they have a job in high-tech city in Hyderabad or electronic city in Bangalore, but they have a farm in Dodaballapur or in Shamshabad. So they can manage everything in their fingertips. They can do their work and they can manage their farm as well. So that agriculture is changing. And especially here he is focusing on better management of input. This is not only the water. He can also manage the fertigation, how much fertilizer is given to the crop. And all the agriculture inputs can be managed. So that, he is doing better. He is doing a very good job now, and he is actually fetching also a lot of revenue these days. And the first person you can see, he is not the person, actually it's a symbolic picture. My friend Taran Jitsing Dhamma, he actually did his BTech from IIT Kharagpur and he moved to IIM Bangalore, IIM Calcutta, and he moved to Canada, I think. But again, he also came back to India and he started a company. And here, when he took his, when you take his mobile app, you can see it will fetch the NPK status. It will actually get the LATAN launch. Accordingly, the NPK status will be displayed in your mobile screen, because already soil health cards have been given to entire agricultural lands in India. All the libraries actually kept ready so that NPK status will come. And apart from that, he will also fetch the hyperspectral images, because in Punjab, Haryana, he is based in Mohali, because they have larger agriculture field. And even the single farmers cannot know what is happening on the other side of his field. So that in the hyperspectral images, he can find out which area is having crop issues, nutrient deficiency or insect attack. Immediately it can be tackled. Considered to be one of the 10 best startup companies in India. This Agnest is about agricultural value chain. So that if you take a Lays or Uncle Chips, if you take one piece of the potato chips, you can find out from where it is cultivated and entire supply chain, how many how many fertilizer is given, how chemicals are added, or everything you will get. So that anywhere on the supply chain or in the value chain, you can trace, the traceability is done. You can trace from where it is coming. If you eat a fish, you know from where, which sea, from whether it is in Veravel coast or in Kanyakumari coast, it is, harvested or it is processed. So that is very important, because especially in European countries, America, they are looking for the traceability from where it is there. If it is coming from the countries which is actually not bothered about climate change or not about emission, they will reject it. And they can also look towards the hygienic conditions and other conditions in the field, in the processing industry and all these things. So that traceability is very important in the future days to come in the food industry. Even FSSAI is also thinking about it. So now you can see AG Next. Agnext is a company, it's a sunrise company by this Taran, the same Taran Brahma. Then similar, I was telling about the irrigation scheduling, different places. Irrigation scheduling is there. If you go to California state in US, Los Angeles, if you go, the farmers first they will download this thing and they will see, this is his farm. He will see, okay, this is my color. Okay, what is the corresponding ET, water requirement of my crops, and accordingly water can be applied. So that it's an open source document. So that farmers will be given information, what is the water requirement of your crop in a real time, and accordingly irrigations can be scheduled. And NDVA also, normalized difference vegetative index. These are actually some of the experience we have conducted in our institute. So you can see in Wayanad district, this is actually map of our Wayanad districts. You can see how, in April and May, how the drought, this one is actually 2007, the bottom one is 2016. In the last 10 years, how the drought, previously it was green, all were safe. Now more areas came under, yellow and red. So that the drought vulnerability is actually high in even a district like Wayanad. So that the future areas are, future days are more tough. And we developed under one of the Egyptian TIFAC Austria program, we also developed, one nutrient, water nutrient decision support system, so that farmers in the mobile itself, farmers will get the information how much nutrient has to be given, how much water has to be given. It is basically, we made a library based on that. It is nothing related to hyperspectral images or sensors. Rather, we took a place, we took the old data, and we, for season wise, we recorded which crop will be cultivated, what is the water requirement and nutrient requirement. Accordingly, information will be given to the farmers. And recently we developed another mobile app. It's called WaterCat. What is CAT? Citizen Assessment Tool. This is basically like you, students, they can actually work here, because for example, Kozhikode I will tell, because we have implemented in Calicut. So that, Calicut, there is a major canal. It's called Canoli Canal. It is connected up to, Kottapuram to Bekal. It's a part of that. So, but this canal is highly polluted in some areas. A lot of impurities are actually coming to the canal, and we demarcated these hotspot areas. And we mobilized a few college and school students like you, and we gave this mobile app to them, and we gave a water testing kit also, so that these guys will go to this hotspots regularly, different hotspots or polluting areas in the canal, and they do the instant water testing. A few parameters we can do using the instant kit, and it will be recorded in the mobile app, and it is connected to the satellite map, so that the mayor can open. Mayor is also part of this. Mayor can open and see every day what is the water quality in different parts of the her jurisdiction in the Kozhikode Corporation, especially in the Canali Canal. So that this map will give, and any place, if the team finds there is an issue, severe issue, they can collect water and send over NABL accredited lab. So it's actually continuously happening. Similarly, another thing, this actually we have not developed, but a farmer came, a person from Maharashtra, Vijay Gavde, he came to our institute almost 1.5 years back. He told that I developed a mobile app, sir, will you please help to validate it, test it. What is that? In a bore well, we cannot know what is the depth of water, whether water is there or not. In open well, we can just go and see. But in a bore well, how we will find out whether water is there or not, or how much depth water is. So that he developed a simple mechanism for that. Because normally bore well, what is the problem? Na? Some days water may not be there. Farmers will be switching on their mobile app, switching on their pump set. It will go dry. It will run dry, and finally pump set will be damaged. So that this one will help the farmers to find out the depth of the water in your bore well. What we will do, you go to the bore well, open your smartphone and enable this mobile app. Then normally in the bore well they have a metal cap, right? You have to just tap on the metal cap by means of a metallic object, as a spanner or any other metallic object. You just tap on the cap of the bore well, so that the sound wave will go down, hit the water table and come back, so that he will find out that he will track the movement of the sound waves, and he will find out how much depth the water is. So it's naturally the velocity of sound, depth, time he will find out, and this algorithm will calculate, and it will give you the depth of the water. And we validated for 450 bore wells in Punjab, so in Palakkad, Malappuram, Thrissur and Kozhikode, and we found out it is 96.7% accurate. So it is a simple farmer developed, and this also it's available in the Google Play. You can see water Pujal app. You can see, you can just type it Pujal app, and you can find it out. Similarly, GA Accu Analyzer, another patented, another copyrighted application. Here actually, if you test water, you put the parameters over here. It will give you the answer for which purpose it can be used, whether it is good for drinking water or other uses, agricultural use or animal use, and if it is not good for any particular use, what type of filter it has to be used, which parameter is exceeded. Every information this app will give. Again, rainwater harvesting is also another area. I will not spend much time because you all know, but as far as India is concerned, we have lot of water, especially in Kerala. We have lot of water. In a small roof of 100 square meter, how much water we get? 100 into 3 meter, 300 cubic meter. That means 3 lakhs liters of water you are getting in a 100 square meter roof, 1000 square feet roof, 100 square meter roof, you are getting 3 lakhs liter. But you have to harvest only 10,000 or 20,000 liters water, because most of us have water. We don't have water only for 2-3 months, maximum 100 days in a year, right? Maybe April, May, 2 months, or maybe March also some, March, April, May. So maximum 90 or 100 days we don't have water. So that in a house, how many people, if you have 4 people, daily you require around 75 liters of water. Accordingly you can calculate. You may require 300 liters of water, and 300 liters of water for 100 days, 30,000 liters of water is more or less enough. So this way actually you can design your rainwater harvesting system. Your supply is much more than the demand. And again here one point, in a roof you have 3 lakhs liters of water, 100 square meter roof. You need maximum 20,000 or 30,000 liters of water. Remaining 2,70,000 liters of water is simply going down or anywhere. So what we can do actually after filtration, because the water coming from the roof, first we will filter. That is very important, because it's drinking water. Then the remaining water, why don't you directly divert to your open wells? In Thrissur you have done, in your district you have done, and you gave a name, beautiful name for that. We call Madapolima. You can speak to Dr. Jose Raphael. He was actually superheading this campaign. So after filtration, the water can be directly given to your open wells. And in a panchayat, if you have 500 families, at least 200, 300 people do this, the water table in that particular locality will rise up. You will get at least water more for 1 month in your summer season. You can see different parts of the country or in the globe. Actually, recently I went to Sri Lanka. They are harvesting roof water because there is no other water. The available water is saline water. So they are actually using it. That is from Nepal. This is from Thrissur only. You can see the water which is coming from the roof. They are actually harvesting in a small syntax tank, 2,000 or 5,000 liters. Remaining water directly going to the well, filtered water. So that is well water recharging. Similarly, that is for drinking water. 20,000 or 25,000 liters is enough. But for irrigation, that is not enough. Irrigation for 1 day we may require 10 or 15,000 liters of water. So that we have to go for larger ponds. These all the ponds actually we designed on one or other way we have connected. You can see first one is in near Karnataka, Mangalore, 4 lakhs liters. We constructed way back in 1998. This one actually in near Kanjangad. Recently the person he expired, Kadudodil Matachan. It was the biggest in Kerala that time, 16 lakhs liters. Then, that is actually in Goa. We have not done, but that photo I have taken. Agriculture tourism, agro-tourism he has constructed. 2 crores it can be harvested. That is actually in Purapuda, our former Minister P.J. Joseph sir's farm, 20 lakhs liters of capacity. This is from Northeast. So different parts of the country, we are actually harvesting water in a big way in lined ponds as well. But of course, it is plastic lined. We have to also see the plastic misuse. But it is a long duration, actually long term. It can be used almost for 10-15 years. So it is worth constructing. Similarly, groundwater recharge. Groundwater recharge, different interventions, different places. We cannot go for all the interventions, all the places. So where contour bund is required, where contour trench is required, where filter strip is required, everything we have to design. The designing is basically depends on the rainfall, the topography, the slope, the management practices, soil type. All these parameters you have to take into consideration and decide which interventions you have to go. Whether it is terracing, whether it is contour bunding, graded bund, or trenching, filter strip, or whatever it is. Check dams. Check dams and all, actually you don't think it is a big dam, you have to spend crores of rupees. You can use the local materials, loose boulders or brushwoods, and construct the dams. These check dams are actually not to, collect water and use, rather it is for reduce the velocity of running water. In rainwater harvesting or groundwater recharge, we have 2 principles. The first principle is catch the water where it falls. So that in our field itself we can catch the water, especially in midland areas, not good for the hilly areas. Midland areas, lateritic areas, it is very good. Catch the water where it falls. Rain pits, catch pits. So the water will go percolate to your aquifers and it will give back during the summer months. The second is reduce the velocity of running water. Reduce the velocity of running water so that more water will get absorbed, get percolated to the soil. Then a few, all different places, it's all connected to SDGs. SDG 6 and 11, it is connected. If you go to, Karnataka or especially, Decade, Dakshina Kannada district, Mangalore and all, or in Kasaragod, they have a traditional way of tapping water. They call it Turangam. You might have seen some of the WhatsApp videos and all, or YouTube videos and all. So this is a horizontal well. Rather than digging vertically down, we dig horizontally, we do the construction. There are some traditional people, they can construct these surangams. So 24/7 the water is coming, pure water is coming out, and maybe 1 or 2 families are using it. Otherwise this water is simply going. So what we suggested, why don't we divert this water to a laterite or granite quarries? If you go to North Kerala, Kannur, Kasaragod, even in Kozhikode, you can see a lot of granite, laterite quarries. In southern Kerala, you can see granite quarries. So it can be converted as a water source. Now our water resource department is also thinking seriously to convert the unused granite and laterite quarries as water reservoirs. This water can be used for irrigation as well as drinking water purposes. Or some dike can be constructed. In the picture you can see there is a surangam on the left hand side. The water from the surangam is actually collected in this dike. Excess water is actually, there is a provision for spillover also. This water is used for irrigation and other purposes. And since water is collected there, recharge is happening in the down as well as. And this also from the Kasaragod, because I worked in Kasaragod for 10 years at CPCRA Kasaragod. So that if you go to one village in Kasaragod, it's called Yatadka. In this village, you can see every year farmers are actually constructing check dams. And interesting thing is actually the amount for this construction is taken by the farmers themselves. From their pocket only they are actually taking the money. And why they are doing? Because they are harvesting this water, and this water they are using it for irrigating their arecanut fields. And you can see a chain of check dams in the Yatadka, across Yatadka river, in the Yatadka Panchayat, Yatadka village. And they have, it's all traditional artisans they are doing, so that they have even a technology to spill over the water also, to down, so that upstream people will ensure that downstream people also get the water. So every year they do this, and they conserve water. We all published all the things what I have shown. We have a paper published. I have given the reference on the right hand side. And another thing, in Imphal, you maybe, Manipur is not in the good news these days, but Manipur is a beautiful place. People are also very beautiful. So that Manipur, if you go in flight, if you look towards the Imphal city from the aeroplane, you can see a big green field. You think it is a big Maidan, big ground, but it's not a ground. Rather, it is a Ramsar site. It's a lake. You know Ramsar site? In Kerala, we have 3 Ramsar sites. What all are? Vembanad, Ashtamudi, and Shastangota. Because Ramsar site, Ramsar is a place in Iran. There actually global leaders assembled and they decided we have wetlands across the globe. It has to be protected. It has to be preserved for the sustainability of the mankind. So that all the global community decided we will protect this wetlands. In India, we had 75 Ramsar sites. In last, this wetland day, February 2nd, another 5 is added. Now we have 80 wetlands in India. In Kerala, we have only 3, but many are qualified. We have Chetua wetland, we have Kawai, we have Kotuli, we have Vellaini, Akulam, so many wetlands. But Ramsar, only 3 are there. So this is one of the Ramsar site. And the area is, 270 square kilometer. Such a big area. 1 square kilometer is actually 100 hectare. That means 27,000 hectare area spread over lake. But you cannot see any water there. You can see only floating masses. They call it is Fumdi. How these floating masses are created? Here also, hillocks are there. I think I have to stop now. Yeah. Hillocks are there across, and I think soil and all the, because of soil erosion, entire soil is coming to this lake, and slowly floating masses are formed. And after that, some farmers came and they started staying over there. Not farmers, fishers. Then slowly it became a habitat. So there is a trade-off. We have to conserve it as a freshwater lake. Same time, we cannot disturb the livelihood of the people. Finally, what we have done, I was also part of the team by the Central Planning Commission that time. So that what we have done, we actually treated the source. We, instead of do the disturbance in the lake. Rather, we suggested in long run how we can avoid infiltration or inflow of chemicals and silt or soil to the lake. So that we motivated the people, the Koki community, tribal community in the hillocks, and we told them it is for your good. And all the interventions, check dams, bunds, everything we have done in the sources in the catchment area, and slowly we prevented the entry of debris and masses or silt to the lake. From green it is again recovered to blue. Similarly, recently we are doing in Rangantittu Bird Sanctuary in Mysore. Here the issue is, they have actually side protection is an issue. They were using the plastic filled bags. But now we suggested, why don't we go for, coir or jute geotextiles. So that now we are actually converting the entire small islets. All these small islands actually, we are actually stabilizing with this natural geotextiles. Similarly, a lot of technologies we can discuss. I will not, I think it's little time constraint is there. Recently in our office, we started a center of excellence on water related climate disasters, the floods, drought and landslides. So to any of you are interested to work in these areas, you can contact us. It's a center of excellence. And this one I was telling about this carbon emission. Recently in Katakada Legislative Assembly constituency, we developed a carbon mapping. We have done a carbon mapping exercise and developed a carbon auditing report. So that we know under the 6 panchayats under this Legislative Assembly constituency, what is the sequestration, what is the emission from different sectors, where emissions are high, which sector, how we can tackle it, and sequestration. So that the MLA is taken a lot of keen interest, so that each area, for example, one side pollution is an issue, more emission is happening. He has done a separate liquid and solid waste management system there. One area transportation is actually creating a lot of emission. That area actually he gave cycles to the students. So he told you come in cycle to the school rather than your parent, your father drop in his scooter. So that much emission can be saved. Similarly, Miyawaki forest and solar systems, so a lot of things, interventions, step by step, it is getting introduced in this Legislative Assembly constituency. So that we developed a framework for that. And finally, I think only 1 or 2 slides are left. So that finally, what we can do as a community, as a student community, what we can do, 2 things. One, we can take a model village, a pilot place, a pilot village, and we have to record the resources. What is the land resources, water resources, how it is getting changed over the years. What is the climate? We have to also actually install a automatic weather station there. So the data we will be getting real time basis. And again we will also map the carbon emission from different sectors, energy, basic sectors, flow, energy, transportation, pollution. Then similarly sequestration also we will find out. And everything we will make together, and based on this we will suggest the interventions to the panchayat. This area emission is more, this area water resources are not managed properly, or this area there is a possibility of landslide. So that everything actually based on the lab, you have a remote sensing and GIS lab here, so you can use the satellite products as well. So you have to develop a better strategies based on the evidences. That is science. So that way we have to develop further. And this is the final slide I have. There are 2 newspaper reports. On the left side you saw, it is about the Meenachil. Meenachil are, maybe knowing, this river, all the floods, all the time this rivers creates a lot of havoc, lot of chaos. And finally the people came together. They created an agency. It is called MRRA, Meenachil Rain and River Monitoring Authority, MRRMA. So that what they have done, the people took money from their pocket, they installed weather stations, they installed rain gauges, they installed staff gauges in the river, and they are monitoring the water and the rain in that particular locality, in the catchment and command area of this river basin, right? And we academicians and scientists are also supporting them, so that all the data will be pulled together, and we are doing some basic analysis, and the information is passed on to the community. So that if anything happens, if a big rain happens on the eastern side, immediately the information will be passed to the people in Pala or Charpangal or Punyar or even the Kuttanad area, so that this much rain happen, maybe flow may come up to this extent, maybe this much area will be inundated, and again water will be coming down. So you should be taken care of. So that the community engaged weather monitoring systems, flood alert system or flood management system or disaster management system. So we have to also think about that. Then finally this one I told, 98, that photo I have shown previously is taken by me in 1998. This is the picture came in Indian Express in 2022 March. So that last 25 years the people are doing the same type of katta, check dams in the Yatharka river by themselves. There is no financial incentive or financial support from Panchayat or any other department. The community engaged, the community themselves are actually managing their water resources by means of constructing check dams and using it. And maybe after one season they will remove just before the onset of monsoon, they will remove the building materials and keep on the nearby field and again do the same business maybe in the October, November months. So this every year it happens. So that thank you very much for listening to me. I took a little more time. Thanks a lot. If you have got any quick questions, you can ask. Otherwise, I will wind up. Thank you.
Thank you, sir, for this enlightening session. I hope the keynote lecture was informative and productive for the audience. Now I invite Dr. Linto Alappat to present a memento to our keynote lecture speaker. Now we shall disperse for a short tea break. Tea and snacks are provided just outside the hall. The tea break is for 10 minutes. Our next session will be taken by Dr. Sujit V. Gopalan.
A very good afternoon to one and all. Welcome you all back to the 2 days multidisciplinary international conference conducted by the ScholarsConnect of the Christ College Irinjalakuda. Welcome you all back. So today morning what we have witnessed is the inauguration session, and from now on we'll be having separate keynote sessions for different disciplines. We'll be beginning with zoology. So today with us we have our resource person, Dr. Sujit V. Gopalan. Dr. Sujit V. Gopalan is an executive and founding member of the Society for Ordinate Studies. He is a well-experienced teacher and has a number of publications in national and international journals. He was awarded PhD from the University of Kerala. He is also the recipient of various awards nationally and internationally, the research grant from CIMO Finland being one of them. So I am sure today's session will not only be an insightful one, but also an enriching session for all of us. So without further ado, I would like to welcome Dr. Sujit V. Gopalan, who will be addressing to us about amphibians. Welcome you, sir.
Thank you. So good afternoon, almost good afternoon now. Maybe don't think it is a session on amphibians. I'm using amphibians just as a model organism or a model faunal groups to say what is the hidden diversity we have, how have the diversity perspective changed over the years, what are the new technologies that's been used now. So molecular systematics is a supporting tool like that, and we'll go into that. So I'll not take much time, we'll go faster as soon as possible. You all can identify this animal, right? We'll make it a bit interactive rather than you being silent and I keep on speaking. You all identify this animal, right? We all see it as tiger, right? And you, maybe people who have seen it in zoos and all identify it. How do we identify this as tiger? There are some morphological features which you believe is of tigers, right? Then we also have some variations in these morphological features. Like you have white tigers, you have melanistic forms, then you have some golden tigers, but these are all tigers. So it's not color that defines a tiger, right? And it is not the stripe that defines a tiger. There is something else. And if you look below also, you can see there is a leopard, there's a black leopard, and if you see that is the body pattern of leopards. That is of a normal leopard, and the second one you see is of a melanistic leopard. And third one, that is of a jaguar. But there is some variations. Leopards have similar rosettes, but jaguar has different one, right? Jaguar has a spot in between the rosettes. So there is some kind of identification keys which you think identifies an animal. It's the morphological combination of some morphological characters. Now, apart from amphibians, we look at other species also. So these are two ordinate species. Okay, and can you say are they the same? Are these two the same? No, I know some of you know that. They are actually two different species. Okay, but they look similar, though you have some color variations minorly in each other. But if you look at, there is something called as a taxonomic key which defines a species. If all characters are similar also, if just one taxonomic key is different, you say based on that taxonomic key, you say this is a different species. And that is what the taxonomic key is meant for. So there may be different morphological characters, but if the taxonomic key is the one which fixes a species, it will not be different among species. Among species it will be similar. So that becomes a taxonomic key. And this taxonomic method, we call it as alpha taxonomy or the morphological taxonomic method. This has provided a wealth of information for us, and this is what we have been describing and identifying species over the years. So we all started with this similar taxonomic methods in amphibians also. So I started my research back in 2008, late in 2008. Well, I focused on this particular organism for my PhD and all. My major research is focused on this organism called faunal group called amphibians. You all know how you identify amphibian. He has a double life because one part of life cycle is in water and other half in land. Their metamorphosis is there, cold-blooded, they are smooth, soft skin, and they are webbed organisms. This is a general characteristic of what you define an amphibian. And when you say it is amphibian, you have three different groups. One is frog, then you have this salamander which looks like lizards, and then you have the snakes like Sicilians. So these are the three major suborders in amphibians. Okay. Now, look at the diversity of amphibians is that this has been, there is a tremendous growth in amphibian diversity right now. New species is being described every day new species is being added. If you look at it in the Kerala scenario also, you can see different newspaper reports coming each day, which describes a new species. And we may be wondering, like we have been, if you look at the taxonomic exploration of Western Ghats or Kerala, it has been centuries now, but still new species are coming up. And where did we miss them? We lacked spotting ability, or what is that? So this is some perspective which I am saying where we're looking into amphibian taxonomy, and we require some revamping, re-looking into these ones. So this is applicable not only for amphibians, it is applicable for your spiders who are working on this, on praying mantis, all lesser known species especially, which has less mobility. These all species requires much more focused expedition into this one. So look at the amphibian diversity. You have some 8,520 amphibians worldwide, and among them, the majority of them are frogs. Anurans are frogs. So 7,571 are anurans. You have 447 described in India, and this number is going up right now. 406 are anurans. 252 species is from Western Ghats. Of that, 226 are frogs. We have 185 species right now from Kerala. Like if you look at the last checklist from Kerala, it was 151 species. And it was published in 2015. From that, when you reach 2024, it is 185 species. And of that, 168 are frogs. And others we have is this salamanders. No, we don't have salamanders. We have this Sicilians, which is legless amphibians. Okay. Now, this was one of the first faunal groups that I focused on while I was doing this work. It's called Rhacophoridae. And one of the interesting thing about this amphibians, when you look at the zoological sciences, one thing I remember one my +2 teacher taught me, he always says biology is the science of exceptions. You say, thus we put a set of conditions for defining something, and there will be an exception for that. Like if you simply look at, we say all mammals give birth, but there are exceptions. There is a mammal called platypus which lay eggs. Otherwise, you also say there are snakes lay eggs, but there is an exception for that also. So like that, it is interesting in such a way that biology always has some exceptions. So this group also has an exception. Normally we say in Rhacophoridae, there is a group called bush frogs, which is Rhaochirtus and Pseudophilotus genus group of frogs. They don't have this metamorphosis, proper metamorphosis. They don't lay eggs in water, and their eggs does not hatch out into a larvae, and that will not transform into a frog. They indirectly, they lay eggs and it hatch out as small froglets. So they lack this metamorphosis stage. So that's an exception when you define amphibians. So in that way, it was very interesting. And second thing, one of the interesting thing is that, do you feel this is one species? But actually it is. It is called Rhaochus recroparalagi, and it is named as if commonly as variable bush frogs. They are variable bush frogs because they have varying colorations. There are multiple colorations available in this frog. And when this frog itself was described in 2009, it was called variable bush frog, which they give 4 different color morphs. And after that, a lot of color morphs have been added. And interesting thing is that about frog coloration, if you look at this brown frog on the bottom and the green frog, they are the same individuals. I brought them into the lab. It was in a bottle. After some time when I took it out, it changed from brown to green. So they have some adaptability to adapt to the surroundings also. So color is never a taxonomic feature unless and until it is similar in all of the species. Now this was an interesting news which came up in somewhere in 2009 late, when this somehow triggered my interest in color morphs in amphibians. See the heading, color changing frog is worshipped as god in India. This was a news, this came up in India, it came up somewhere in Britain. And this news was sent up from there to us because Dr. Uman, who was the chairman of Biodiversity Board, he had some collaborations in London, and this came up to him. And interestingly, he had a frog in his lab, which was caught and kept in the lab, and it was changing color when it's kept on different surfaces. And somehow there is small manipulation in news, and they made it more interesting by saying that it is worshipped as god. But he put his statement down that it is quite common in color variation in amphibians. So now this is another group of frogs called Pseudophilotus. Okay. How many species are they? So actually it is 3 different species. Very closely related, 3 different species. Initially, these were all Pseudophylotus wienerdensis, but right now we know we have one species in Trivandrum, one species on some part of Trivandrum, not fully Trivandrum, one species that extends from Trivandrum to Kannur, and another species apart from Kannur, there is another species called Ambavali. So there is 3 different species. Okay, now I was studying the species. Do you have a confusion in right now? How many species are there? Actually, these are 16 of them are one single species. So this is where you could eliminate these confusions simply using a molecular tool. Okay, because there is large diversity, especially when this hotspot. If you look at amphibians, there is huge diversity. If we are looking at ordinates also, people are there, huge diversity of ordinates. If you look at Delhi, they have some 30 species ordinates, but in Kerala we have somewhere near 190. So that is a diversity we have in Western Ghats, huge diversity, and much of them are similar, very similar to each other, cryptic. You can not identify the adult forms, and you cannot think about the larval stages or the nymph stages. They are quite too similar, and this is the one key factor where we missed a lot of species. So we had a lot of species which are very closely similar to each other. Okay, and most of them were misidentified. So this coloration also made a quite difficult job. There was one species called Rahostus Neelanethras. Okay, it was described based on its eye color, because Neelanethras means blue eyes. Okay, and this species description came up in one of the prestigious journal called Zootaxa. And after some years, when people re-looked into this taxonomy, they identified that these two were same frogs, because there was another earlier description called Lavochustus luteolus, which also had the blue eye. But somehow the author missed that one. And he had some morphological characters which was different from that one, and he thought this one is for the new species. But when they did a molecular tool and made a further study, these two were the same species. Then they synonymized this one. So this is the confusion in taxonomical things. But you all know, for conserving an organism, this primary need is to identify the organism. You should give a name to the organism. This is the primary need in conservation. Okay. Now, this is also not enough. You just name the organism, that is also not enough. You need to know what is their population status. So seeing such color morphism, such color variations, we took up some genes from this organism and started to look at its population status. So interestingly, you know, if you look at Western Ghats, we have 3 major geographical barriers, which is geographical barrier for some species it's not a geographical barrier. It depends upon which species you are looking at. Not even looking at what faunal groups. Like, if you take Western Ghats, you have this Sengota gap, you have this Palakkad gap, and there is a Goan gap. Okay? If you look at the time scale of these gaps, they are formed a lot of years, millions of years back, some 200 millions of years, because they were formed when the Gondwanan continent started moving from Australian coast to hitting back to Asian coast, Asia. So they have some 200 million years in their formation. Some are 135 million years, some are 150 million years. So this is the range of each geographical gaps. Okay. So for some organism, these are major geographical barriers. You know major geographical barriers. When you say geographical barriers, there is no inbreeding between two faunal groups on either side of that. So that is a geographical barrier. So we were looking at if this geographical barrier were evident in this frog called Pseudophylotus wienerdensis. What we did, we took out one common 6-genus DNA, because that has some population genetic signal given by this gene. It is also used for a gene of barcode. You understand when I say it is a gene of barcode, right? Gene of barcode is the one which says the gene is very conserved. It will be almost similar, 99.9% similar among species. But it will show some variation between species. But interesting thing about the 6-genus rRNA gene is that it is a ribosomal RNA gene. It also shows some population genetic signal, because it will show some haplotype variation between populations. So interestingly, I took out this gene from this organism, did a barcoding, and saw that these are all one species. But when I look at the population status, if you look at Idiki cluster, there is a Ponmudi cluster, because Idiki cluster is between Palakkad gap and the Sengota gap. Below Sengota gap is Trivandrum area, that is Ponmudi cluster, and above Sengota gap there is a different cluster. Okay, so there is some population variations, saying that this species has limited gene flow among them. I mean, this population has limited gene flow, and if you take another 50 million years or 100 million years, each of this frog is going to be a different species. So they are all evolving into one species. So this is something that is happening in Western India. All species are somewhere at some point of time independently evolving into different ones. So this also is a representation for that. Now, one of the interesting things, these are all eyes of frogs. One thing I'll make sure that you will change your perspective about amphibians today. Because amphibians has been long been thought about very ugly creatures, they were not interesting. But today, I'll somehow change your perspective about these amphibians. Look at these eyes. This is a recent trend now. People started using eyes, frog eyes as a taxonomical feature. And thus, if you look at, this is one single species of called Rauchus Jairam's bush frog. If you look at the eyes, they have morphological difference, but they have the color variations among them. But if you look at the eyes, all eyes are similar. The eyes have similar pattern. That blue shade below the iris is there, then that marking on that retina is there. All those things are similar for all those frogs. But interestingly, there is also some variations that is shown in other frogs. Like this is Rauchus jairami you have on your extreme left. The other two are Bedomi. But in Bedomi also, when it comes to ranges between 1000 to 1200 meters, it has a red eye. But if it goes to 1500 meters, the eye is somewhat silverish in color, bluish silver in color. So, but similar pattern is the design pattern is all same. Okay. Now, like we also have this one issues in amphibians. Not only in amphibians, when I say it's a morgal organism, it happens in every other faunal groups also. We describe a species in one particular location. But after that, we don't know what is the range of the species. Where all is the species present? Like this frog species called Mercurana meristica patricus. It is called meristica swamp frog in common. It is described from below the Chengota gap, from Kollam and Trivandrum area, below the Chengota gap. They are found in meristica swamps. In Malayalam, we call it Kattujadi Chadup. It's a type of swamp. An interesting thing about this amphibian is all other amphibians start breeding in monsoon season, when we have the southwest monsoon coming in, June, July time. But this guy, he starts breeding earlier to the monsoon, in the post-monsoon, pre-monsoon time. When we have the summer showers, these frogs descend from the treetops. They are normally found in treetops, otherwise it is not found. By pre-monsoon showers, they descend down the treetops, they lay eggs in the swamp, and after that, they climb back. So we see them in May and before rain by June. Okay, May, June time, before the rain, we have this frog presence in all the meristica swamps. After some June, mid-June, there is no adult forms. All are climbed up. All we have in down is that the eggs that is laid in swamps. So by rain, the swamps is flooded, the tadpoles hatch out, and the subadults are formed. And by the time they are adult, they climb back to the tree. So this is the particular morphological behavior shown by this frog. So this is why this frog was described in 2012. Until then, this was not known, because only it is known for this very short period, like our Nasica batragus, the purple frog. So when we went for a survey, there is a post-flood impact assessment survey we did for Kerala State Biodiversity Board. So when we went for that, we heard the sound of this frog from one of the meristica swamp in Varachal. So initially I was confused because we heard the sound in late June, July, early July somewhere. Because by then it should have gone back to the trees and sound should not be heard. But they have a different breeding pattern in Varachal. They are breeding late. They are breeding with the monsoon there. So I thought it should be something different is there. There is some breeding difference in morphology or something should be there. So we collected the frog from there. And we looked at the morphology in detail initially. But I didn't find any morphological difference. Still, there was a breeding change and behavioral change and all. We did a molecular thing of this one also. But its molecular work shows 100% similarity with the already described species from Chengota. So we fixed the species as meristica swamp frog. And now this frog is found. We understand that this frog is not only found south of Chengota gap. It is found in many of this meristica type like patches in Thekkan and Varachal, in Parambikulam and Aries area. So this is as a wider distribution. Now we understand that. And this is how you, this tree, hope you understand the basics of phylogenetic range. When you have good bootstrap value and they cluster together, we believe it is a same species. And second thing you normally basically look at is that you look at the genetic distance. What is the genetic distance between that and the already described specimen? So the species number RA1159, what is given? It is from Varachal, and the meristica patricus returns. It was from Chengota area. So you see there is a hardly 0.62% genetic variations. Normally sees that if you take a 16S or CO1 gene, should have some 3.5 to 5% genetic variation. That is the normal slab, but there are species which is described below the slab also, but in that case they have good morphological variations. Here they didn't have much morphological variations, but since it was on the other side, two sides of the gap, it had some population segregation going on, some allele flow is not there, so they had some genetic variation and showed 0.62%. Okay, now this is also an interesting thing about Nassica patricus, we'll skip that. Then this was another interesting group of frogs called Dicroglossidae, which we have this rice frogs called Fegevaria, Menavarias, now Spirothecas. These all genus come into this. And one of the interesting genus of frog in this frog is called this Euphilictis. We all know these frogs. Like we have seen them in small puddles. You can see the eyes up in the water, floating on the puddles. We have seen a lot of this frog, and we have two varieties of this one normally called. One is this bigger, large green color pond frogs that you find in ponds, larger swamps, in wetlands and all. And other smaller varieties which are less brownish in color, you find it in puddles of water. These two are the basic things that are. Now, this larger green frogs, they have changed the genus to Phrenoderma. They are not all Euphilictis now, they are all Phrenoderma. If you remember, for people who have learned zoology by dissecting, when we were in colleges, we had this frog specimen, large frog specimen coming to us, and they were all said to be Euphilictis hexadactyla. And we have a lot of specimens in colleges, which we say it is of Euphilictis hexadactyla. Because all green frogs found from the western coast, we all considered them to be Euphilictis hexadactyla. And this was like, we were trying to describe a new species. It was not from Kerala, it was from Bangladesh, because we had some collaborations with Finland and similar. So we are trying to describe a Euphilictis species from Bangladesh. At that time, I started sampling these frogs. I wanted to have some sequence of tissues of hexadactyla and some tissues of this Euphilictis cyanophilictis from Kerala to fix that, because we had the type locality here. Because type locality of this hexadactyla was in Pondicherry and Euphilictis was in Kerala itself. So I collected these specimens, I sequenced them. But one of the interesting things I found is I never found a hexadactyla in Kerala. I started sampling starting from Trivandrum up to Karnataka. I started sampling and I didn't find even a single hexadactyla sample from anywhere. Then we looked detailed into morphology. There was no morphologically similar specimen to hexadactyla. Then what I did is that we went to the type locality called Pondicherry, took a frog from that, I took a gene sequence, and then I understood that we didn't have any hexadactyla specimen in Kerala. Previously, this hexadactyla had its range throughout India. All the coasts of India on the eastern and western coast, these were all called as hexadactyla. The large green pond frogs all found was hexadactyla. But now the status is that we have 3 different frogs in this entire range. Western coast is by hexadactyla, eastern coast is by Caravelle, and we have this recent description of a green frog from Tattegad area which is called Phrenoderma Kerala. Now, when we did this entire molecular thing, one thing was very evident is that we don't have Phrenoderma hexadactyla in Kerala, nor in western coast. All those hexadactyla specimens that we found in Kerala, the larger ones, all were Euphilictis Caravelle. And then we had another smaller varieties of green frogs called Phrenoderma alochi and Phrenoderma cala. I said this large green frogs are now renamed into Phrenoderma. They are no more Euphilictis now. So this is how you miss some species. When one frog, we believed all these to be hexadactyla, but where actually there were 3 different species. So this is another group of frogs called Microhyla. They are called narrow mouth frogs because they are very narrow mouth. And one interesting thing is that they don't have any morphological difference between males and females. You know, there is sexual dimorphism in much of the fauna groups. Males have some characters which is makes very evident which you can differentiate it from females. But these frogs, sexual dimorphism also different, but they had one of the most beautiful frogs. Like if you see Melanobatrachus, there is one frog group called species called Melanobatrachus indicus. We call it as galaxy frog. So one of the most sorted frog to be photographed. And people are running after that to get photographed. So they are a lot in that group. So one of the things was that we had this one species we had 2 species earlier in Kerala, which was very known to everybody who was working on amphibians. One was Microhyla ornata, which was a smaller species, lightly colored. And another one was called Microhyla rubra, which was a reddish species, which is these 2 were easy to be identified in scale. So when again we are trying to describe a species, we started sampling Microhylas from Kerala. I wanted to get a specimen of Microhyla ornata and one of rubra and their genetic samples because we need to sequence few genes to get this species described. But when we started that, then I came to know that we have multiple species in Microhyla ornata. Lot of species, but we were not able to, now they have been described. We have Microhyla dareli, we have Microhyla lateralis, all those came up because earlier all those things were thought to be Microhyla ornata. Now, one of the interesting things is this species called Microhyla niloparamensis was described by a group from Bangladesh, because this guy was from Bangladesh. And interestingly, when I started sampling, I found that this was described from Bangladesh. After that, when I started sampling, I could see the presence of this frog in our area also. Because if you see, only a small portion of this species range is in Bangladesh. Major part is from India. We had this specimen all over India, but we missed it because we all thought it was Microhyla ornata. I'm going a bit fast so that we'll keep to the time. If you don't follow at any point, let me know because moving faster. So this is one of the species which I started my work in frogs because I was into a project called, I was trying to learn population status of a faunal group in Kerala. We had a project we called Indirana frogs. We had to need to the population status. We want to understand what is a population, how should be the gene flow between population, how is the gene flow within population in Western Ghats. We don't have any data earlier on. So we started with this project, but actually, this was also a very challenging one because this frog is found in Western Ghats, entirely endemic to Western Ghats. This lineage is also one of the ancient lineages in Western Ghats. And one of the interesting things is these are leaping frogs, and you understand that we all understand that frogs lay eggs in water, eggs hatch out, and we have this free swimming tadpole forms. But interesting thing about this frog is that they are semi-terrestrial. The tadpoles are not found in water, but they are found in rock cliffs with small tickling film of water. So, and right now we have two genus in this group, Indirana and Velkarana, two genus in this group is there. And as if I said, they have also had a large number of color variations. One species also exhibited in multiple colors. So it was too difficult to initially fix the taxonomy. And when we started progressing, it became more and more difficult. Like we had to take up populations, and we had some up to Mumbai to entire Western Ghats coast, we had to take populations. So I sampled some 80 locations in Western Ghats to take the population. And because we are starting from the scrap, we don't know what number of individuals should be there to represent one population. So finally we came up that we need to have at least 25 DNA samples from each of the sampling site to describe one population. So I started sampling this population. Along with that, I started to clarify the taxonomy also because it was quite difficult to see. Because these were morphologically very similar species, and apart from that, if you want to sample tadpoles also, tadpoles were very similar. You cannot identify tadpoles from each other, very similar to each other. So initially, we started with this sampling tadpoles also. It was similar. These are three different species tadpoles, but they all were similar. So initially, we started fixing species, how they look like, what is the tadpole stages and all. So for that, we started sampling different life stages of each frog. So this was one of the publications on called Indirana semi-palmata frog species called that. If you look at, that is the adult male is there, adult female is there. Male has this larger tympanum. Female is there. That is the eggs they lay on the log surface. Then that is the another stage of the eggs when they are fertilized and they are much bigger. After that, tadpoles come up in a small film of water. Then they have the first free living tadpoles come, which is on rock surfaces, which have a tiny forelimbs. Then their hind limbs comes up faster, and then they have the jumping frogs. And after that, they almost form froglet and they leap out these eggs. So we have to describe all these tadpole stages. But how do you do that? Because they were morphologically very similar. So I need to take up a rock surface, identify the adult, take out eggs, sequence the adults, sequence the eggs, and then identify each life cycle. And then in this paper, we described each life cycle stages. This is the life cycle stage, and this is how it looks like. This is the length of it, this is the body size, and this is, we classify it based on Gostner stages. So these were possible only because we had this morphological tool. I mean, not only the morphological tool, supporting molecular tool. Because we could take out the genes from all of them, compare them, and identify how they each look like, and then they describe it. Okay. Now, when it came to one species called Indirana bedomi, we planned to have our population genetic study based on just one species. So we took out this frog, we started sampling tissues from each of them, and we started to identify the morphology of each of them. And it was very challenging to us because they were similar to each other. We didn't see any consistent morphological feature which we could fix as a taxonomy. Then, unfortunate thing was that all these type specimens was there in Natural History Museum, London and Paris, because these frogs were described in 1880s. But one of the interesting things was that what they preserved, these specimens were preserved in Natural History Museum, London and Paris, but the preservation was very intact. Like it is not like in our repositories, they maintain it very well, and as if freshly sampled frogs. They didn't have any issues with that. So if you look at the specimens, these are all type specimens. So these, which I marked in that one, these are type specimens. They are sampled in 1880s. So they are as if freshly preserved ones. They didn't have any malformities. They didn't have any issues. Even you could extract DNA from the liver and other tissues. So they were well intact. And once we did the type specimen study, one of the interesting things was that even the person who described the frog, he had this confusion. Because when I looked at the type specimen series of a frog, the holotype is the one which describes the species. Holotype was one species. When I looked at the paratypes, one paratype was a different species and another paratype was a different species. So this one collection of this holotype type material, it was 3 species actually. So we had to fix that initially. We described it from the holotype, took that holotype description. Then we came up to understand that the Indirana Badomi frog, which was known to be found starting from Kanyakumari to top into this Gujarat area, these were 4 different species. They're not one species, there were 4 different species with some morphological variation. So that is how, if you look at these are all specimens which you see here, these are all said to be Badomi. These are all Badomis. And then when you looked at the genes, you see they are entirely different clusters. So this was not done based on one gene, because we were very much careful about this one. So we used 4 genes. Like we had 16S rRNA, cytochrome oxidase 1, cytochrome oxidase B, oxidase 1, cytochrome oxidase B, and also 12S. These 4 mitochondrial genes, and we used rhodopsin and another one, rhode. These 2 nuclear genes. So this is a tree constructed based on 6 genes actually. So it was a very sound tree, and we published that, and it was very well known. We had this confusing species were all clarified. Then we started fixing morphology of these species, and then now we understand what all pockets which frog was there, what all type of morphology are exhibited, and then we started to identify the species, and then we find that there is 4 different frog species in Western Ghats. But when we came to that, our initial project was in a problem, because we wanted to do population genetics of one frog species throughout Western Ghats to identify, but there was no single frog species which had a complete range of Western Ghats. So when we initially started to look at Badomi frogs, we came back to look at Brachytas of similar species. And when we did this, you should see we took up 12 populations south to our Palakkad area. This is 12 representation of 12 populations. And when you look at this, these populations are from south of Chengota Gap. Okay. This population is between Chengota Gap and Palakkad. Vadachal area, up to Vadachal area, and this north to that. So if you look at that one, there these what you see the blue coming up in green and green coming up in red. These are all gene flows, because they are separated. They have different allele groups. Like this is not done based on our mitochondrial genes. These are called mitochondrial microsatellites. Microsatellites are used to do population genetics. So we took out microsatellites. Like we had some 62 markers of microsatellite. These 62 markers were sampled out. They were sequenced, and then we compared that one. So we saw there was some gene flow, some allele sharing is there between these populations, but normally these populations all were independently evolved. So if you consider this one to be Badomi and only conserve this one, you lose this particular gene. If you conserve this one, you lose other two genes. So we need there's a conservation implication after the study. One we understood is that if you treat Badomi as a single species which has range starting from Kanyakumari to up to your Gujarat coast, you will understand that this is one single species, and it comes under least conserved category. They are classified as least conserved. But if you look at the other way, like if you look at it as a multiple species, each species will have lesser range and each requires much more focused conservation effort, because they are multiple species in one particular. And if you see that one particular species is going to be extinct in one particular area, like there is a local extinction, you are losing a particular gene. Because in Western Ghats, when you consider conservation of any species, each area has a uniquely evolving gene pool. They are uniquely evolving into one particular species. So we cannot lose any species at any point. All those local conservation important because that only can maintain the frog species. Like if you believe one particular area, they are evolving independently, and there are some allele being given to each other. So they have some allele variations, but they also independently evolve. So even if a disease is struck in one particular area, there is some chance that it survives. So that is very difficult to understand this conservation. So if you look at the evolution perspective also in Western Ghats, if you look at some frogs, they have wide range. How do they have wide range? But like if you look at the Nilapparamensis, that microhylid frog, it has a range starting from Bangladesh to south to Kerala. We have up to Paramikulam area, we are recorded species. So this one particular species has this long range thing. Okay, but there are some frog species which are limited to one particular area. How come it is one faunal group is evolving differently? Have you ever thought about it? We have some species which has very limited range and some species which has very wide range. Why is not that species split into different groups? Because now we understand we are doing all molecular markers. We are seeing the gene variations. We are seeing the allele variations using mitochondrial markers. And we understand that that is a solid long population. And one population which was we thought to be such long as different species. Why is evolution in different perspectives? Like it is, why is not Nilapparamensis split into different species and Badomi split into not split? Nilapparamensis not split into different species and Badomi split into different species. Why is that so? Have you ever thought why is evolution going in such way? Any idea? See, one of the interesting thing, one paper came up in 2016, which was they were working on a Sicilian group called, there's a Sicilian group, it's called Ichthyopus bedomi. So these had 4 different species in Western Ghats. They were described from, one species was initially described, then they described 4 different species. They were entirely designated into different species based on morphology. But when they started studying the species, they found that each of the species was similar to each other genetically. And then they synonymized this into one single species. Okay, now that is Ichthyopus bedomi is one single species which has wide range. So there is one species of that kind. Now they define and say that why is this species with such long range? They say there is a type of evolution called bottleneck evolution. What happens in bottleneck evolution? One species with such large range slowly starts dying off and becomes concentrated to one small area. Then it is almost in the verge of extinction. When situation becomes favorable, they start spreading back. So what happens? Evolution time of this particular group which is small, it is coming back, diversifying. Evolution time is small. Okay, it takes millions of years for one single base pair to change its status. Okay, one mutation to take place in single base pair to accommodate that, it takes millions of years. So this time frame is not given. So such species which has come up in evolution like bottleneck, that is one single species with larger range because they have been recently diversified into this area and their range has recently been extended. But there are some other species which has been there in this hotspots for a long time. Like they have been evolving along with this habitat. They have never come down into a particular area. They have been evolving. So what happens is that because of the habitat pressure and the environmental pressure, they start adapting, and this adaptation accumulates different mutations, and they start evolving into a single species in each point of time. So if you take at Western Ghats, we have such long evolution. Like you say Western Ghats is older than Himalayas, right? Why is that so? Because Western Ghats started its formation when it was starting this with this migration, continental migration. Western Ghats started evolution there. So species that was co-evolving with this habitat started evolving at the time Western Ghats started its migration. All those geographical gaps became evident for them at the time of evolution. Himalayas were formed only 180 years back, when 60 million years when it hit into the Indian subcontinent. I mean, hit into the Asian subcontinent. Then it became the folded mountains. So Himalaya has lesser time of evolution compared to Western Ghats. This is a bit molecular taxonomy along with evolution is interesting. You need to take time. understand, but you cannot, it is not, it is not independent as such, because you cannot simply use molecular tools and start identifying and describing species. You need to have first a solid knowledge of this alpha taxonomy, molecular taxonomy. You should have solid knowledge of that. Then you start building this like molecular tool to support them. Because first, if you want to identify, if you see, I say this is a species A, and this is another species. How will you compare it? What you have first fix, this is a species. You need to fix this species. You need to know what is this morphology. Then you fix this as a species A. You could take out the gene from that and say this is the gene of species. Then you can take a new species, take out a gene and say, compare these two genes and say, yeah, this gene is different from this. This is how it should work. Otherwise, you cannot independently take out molecular taxonomy and start describing species. This is how it works. You know, this is one of the species that is very much going down because of this climatic change, anthropological activities, invasive species and pathogens. There are a hell lot of examples worldwide saying that one of the faunal groups that is facing the largest threats. Even we have this cultured fungus which wiped out many species from South Africa. We also have this South American species being wiped out by some fungal groups. Climate change, like if you have 1 degree shift, it is going to kill many species because they need a very ambient temperature to survive. Like if you take it, look at this species, it is called as Rauchetus resplendens. So this is found in skyline ecosystem. Do you understand what is skyline ecosystems? Sky island ecosystems, I commonly say sky island ecosystems. Like if you go to Munnar, the peaks has a particular ecosystem. It's like some 1,500 meters to 2,500 meters above sea level. So these are the very particular ecosystem which has very particular climatic conditions. They are shorelands, they are grasslands. This is the type of ecosystem you have in the skyline. These type of frogs survive in those ecosystems. There is something going in frogs and other species called altitudinal shift. Like when temperature goes up, what happens? Some species may require 25 degrees Celsius to survive. What will they do? They'll start climbing up. Because when you go up, the temperature comes down. But frogs like this, they are already on the apex. They are on the tops of this Western Ghats. There are no place to move on. So if it is going to have a 1 or 2 degree difference, either the species to get adapted to that, but for a species to get adapted, it requires large number of time, huge time. But now the temperature is shooting up faster. Within 10 years, you are going to have 2 or 3 degrees. They don't have the time to adapt their body temperature to this particular level. So species like this is going to extinct from surface very soon. So I hope I made a faster presentation. So thank you. I'll close now. If you have any questions, you can shout up.
Now it's time for some clarifications. If any of you have any clarifications, you can kindly raise your hands so that I can bring the mic towards you. Do you have any doubts?
So in classical taxonomy, we studied species is a group of organisms that can reproduce and form a new generation, right? Second generation. So by studying these morphological characters and genetic molecular studies, do you believe it is satisfying with that definition of species?
No, like this is what I said initially. Biology is a science of exception. You believe there is when you say, what is your species concept, you say it should be morphologically similar, right? And it should be different from other species. Then you say there should be reproductive isolation. And one species cannot breed with other species to be a biology. To look at all these classical taxonomy concepts of species, all these things are viable. There are hybrids, viable hybrids. Even if you take the examples of rock, there are viable hybrids called Eucalyptus esculenta. Rana esculenta, one species there in Europe. It's a hybrid between two different patterns, different species group, and it's a hybrid. And it is more viable and more vigorous than both the patterns. So you don't understand what is that. So we have this cryptic species. What is cryptic species? They are different species. If you take up the molecular and morphological work, they are different species with different genes, different variations in genetics, but they look similar to each other. But we are saying in our perspective, there are morphological species which that species may look at and understand each other. But we have then this molecular work, yeah, which all genes you did. They say you do mitochondrial genes along with say nuclear genes. Nuclear genes to avoid the concept that that's not a high. Mitochondrial genes to define. And some people even ask the acoustic because crop sound. We identify crops in field hearing the sound because each frog has a unique sound. Call is different. So that is why this species concept itself is very complicated. So to better understand you utilize along with morphology you need to utilize additional tools like acoustics, bioacoustics or molecular. So you're clear?
Thank you, sir, for clearing the doubt. Anyone else with any questions? Yes.
Do journals accept papers based on morphology alone these days? In the case of amphibians, because in all the recent papers that I see, the morphological characters are supplemented with molecular data also. So is it that this has become compulsory now, or?
It's almost like compulsory now because I don't know it is going in such a way. Usually from 5 years back also I've seen papers which they understand and accept species with morphological variation. But right now if you look at all those publications coming up and all those new species coming up, one interesting thing you will notice, there is no species new coming up which is morphologically entirely different. It's an entirely different set of morphological characters. All species that we have described now is scripted. Very similar to morphology to each other and we have some of these patterns. So even the reviewers find it difficult to accept it based on morphology. So they ask for, not only they ask for molecular gene, they'll ask specifically, so did you do mitochondrial genes, what is your final signal of that, what is your nuclear gene, what is the fiber. So they want to avoid all the circumstances of a misidentification because we have nothing in the past. So they'll try to avoid hybrid complications using nuclear genes. They'll try to fix the molecular genes using mitochondrial genes, and then they need this taxonomy, proper taxonomy. So then, like this refining, I think it is refining in such a way. But it is unnecessary also at a certain point of time when we have enough characters, morphological characters or taxonomy.
So if we look at other taxa, for example, what we work on, maybe most of us are working on insects. So what do you think, how do you think it would change? I mean, if you start applying molecular biology here, do you think it will be similar to amphibians? Are traditional taxonomies in threat? Because we don't know much of molecular biology. So if you are forced to do molecular biology in the future, and there is another angle to it because most of the institutions do not have, these sophisticated labs. So that's a threat.
Because like, we have been looking into organics, but that also to understand that now when you also describe species, the thing is that we start like you described the species of chemistry. We are very similar, but we have missed it in the past. Somehow it came back to it's an understood that. So at that point of time, I think there is a certain need when maybe it is not required when you could define proper appendages diagram and other
one more question. I hope it's helpful for everyone. So is there a particular reason why the molecular taxonomy has become a trend in herpetofauna?
One thing is that I understand that we had some past incidents where we had, as I said one example, we had incidents where we had described new species from an existing species. It was entire just morphological variations between two different geographical entities, but somehow they have tried to identify it as a key and then spread. That point of time, like scenarios is that there were instances where color morphs were also described. So at this point of time, nuclear genes came and people started using to complement it. And they also has, if you do nuclear genes, you could support it as bioacoustics, because frogs' calls are unique. They agree to that. If you can supplement it with bioacoustics, that is used. And also, usually in earlier papers you could say they were already describing based on morphology. Now they are asking for stats. You measure the morphological features, PWCA, show what is the morphological variation. That is used. So I think it's refining taxonomy, but yeah, it's getting difficult to express. Like if you, and also the time, like if you just send a paper to Sutax and all, it's gone up. Because it takes a lot of time. I think yeah, they have even 60 days time, but normally your that doesn't come out in 60 days.
Thank you.
Do you have any other doubts? No. Actually, I can see some faces waiting to have some lunch. So, okay. Yeah. Anyway, thank you, sir. From my point of view and from all the research fellows over here, we thank you so much because sir has a train at 3 p.m. Even in his busy schedule, he found out some time to come and share with us his research area. And personally, from a very different background, not even a science background, I'm from a commerce background, at least looking at those pictures gave me some sort of pleasant feeling. So thank you once again, sir, for finding your time and coming to us and joining us today. It was our pleasure and honor to have you here.
Thank you for being here. Thank you.
Yeah, as a token of appreciation, we have a small memento for you. And for presenting the memento, I would like to invite Dr. Sudhikumar, the HOD of the Zoology Department. We welcome you, sir. Thank you, sir. So with this, we have come to our first session. We have come to the end of our first keynote address. So all the PG students can leave. You can go and have your lunch. And please be back by 2:15. Okay? The zoology research scholars, please stay back. We'll be having our presentations now. Okay? The zoology research scholars, please stay back. And the PG students, you can go and have your lunch and be back by 2:15. Okay, so because you guys need some time for lunch. I can see some faces here and there. So you guys go have your lunch and come back. Research scholars, please stay back. Okay, we'll be having our lunch in between. Okay, ജിയോടാഗ് ഫോട്ടോ എടുത്തിട്ടുണ്ട്.
അവർ നേരത്തെ നമ്മൾക്ക് വേണ്ടി
Okay, once more, very good afternoon to one and all. So we'll be starting with our zoology presentations. As of now, we have Sudhi sir and Vijay sir for evaluating us. Later on, we'll be having some changes in the judgment panel. We'll be starting with Shilpa's presentation. So the total time of presentation is 10 minutes, out of which 8 minutes will be for presentation and 2 minutes will be for question and answer session. So without further ado, let's start. So first we have Shilpa.